Sejarah riset dan ilmu pengetahuan Republik Indonesia dimulai sejak tahun 1948, yaitu sejak kelahiran Organisasi Penyelidikan Ilmu Pengetahuan Alam atau OPIPA. 8 tahun kemudian, lahirlah sebuah lembaga riset bernama Majelis Ilmu Pengetahuan Indonesia atau MIPI. Lembaga ini lahir atas permintaan Presiden Soekarno kepada Sarwono Prawiro Harjo yang kemudian menjabat sebagai Ketua MIPI. Sarwono Prawiro Harjo memiliki banyak andil dalam membangun lembaga keilmuan di Indonesia. Tak hanya MIPI, dokter dan guru besar ilmu kebidanan ini juga membantu lahirnya berbagai organisasi profesi kedokteran. Sarwono dikenal mampu mengembangkan berbagai cabang ilmu pengetahuan, sekaligus memimpin para ilmuwan dalam sebuah harmonisasi ilmiah. Ketika teknologi atom atau nuklir mulai populer, pemerintah Indonesia berusaha mengembangkannya dengan tujuan damai serta kesejahteraan masyarakat. Hal itu diwujudkan dengan pembentukan Dewan Tenaga Atom dan Lembaga Tenaga Atom. Lembaga tersebut kemudian disempurnakan menjadi Badan Tenaga Atom Nasional atau BATAN. Tonggak penting penelitian dan pengembangan tenaga atom lainnya ialah peresmian reaktor atom pertama, yaitu reaktor Triga Mark II di Bandung. Masih terbatasnya ilmuwan pada berbagai bidang teknologi juga menjadi salah satu perhatian besar Presiden Soekarno. Melalui program beasiswa Ikatan Dinas, pemerintahan Presiden Soekarno mengirim ribuan pelajar untuk melanjutkan studi di berbagai negara. Sebuah tonggak dalam perencanaan pembangunan hadir dengan ditetapkannya garis-garis besar pola pembangunan nasional sistem semesta berencana. Di dalamnya terkandung perencanaan IPTEK yang dikenal sebagai Visi IPTEK 1961-1969. Saat itu, Presiden Soekarno menyampaikan bahwa MIPI harus segera diubah menjadi Badan Penelitian Nasional. Menurutnya, lebih baik hanya ada satu lembaga IPTEK tertinggi di Indonesia. Hal ini untuk menghindari tumpang tindih dan pemborosan anggaran. Untuk memperkuat sisi kelembagaan, pemerintah kemudian membentuk Departemen Urusan Riset Nasional atau Durenas yang dipimpin Sujono Junet Pusponegoro. Posisi MIPI kemudian menjadi di bawah naungan Durenas dengan tugas tambahan membangun serta mengasuh beberapa lembaga riset nasional. Sarwono Prawiro Harjo sebagai Ketua MIPI juga diberi tanggung jawab ganda sebagai Deputi Menteri Riset. Sementara itu, pengembangan teknologi kedirgantaraan nasional dimulai dengan dibentuknya Panitia Astronautika oleh Perdana Menteri Juanda. Keberhasilan proyek roket yang melibatkan perguruan tinggi dan militer ini kemudian dilanjutkan dengan membentuk Lembaga Penerbangan dan Antariksa Nasional atau LAPAN. Pada tahun yang sama, pemerintah juga membangun National Research Center Cibinong. Gunanya untuk mewadahi bermacam fasilitas riset di berbagai bidang ilmu pengetahuan. Perubahan kelembagaan berlangsung dinamis pada pertengahan tahun 60-an. Hal tersebut diawali dengan penggantian dan perubahan status Durenas menjadi Lembaga Riset Nasional atau Lemrenas. Tahun berikutnya, pemerintah membubarkan Lemrenas dan MIPI, lalu membentuk Lembaga Ilmu Pengetahuan Indonesia atau LIPI yang dikepalai oleh Sarwono Prawiro Harjo. Aktivitas riset dan pengembangan IPTEK kembali menggeliat ketika pemerintah menunjuk Sumitro Joyo Hadikusumo sebagai Menteri Negara Riset. Ia berkolaborasi dengan B.J. Habibie untuk merintis pembangunan industri pesawat dalam negeri, kawasan riset terpadu, serta sebuah badan pengembangan teknologi. Kawasan riset terpadu dan terbesar di Indonesia berhasil terwujud dengan didirikannya Pusat Penelitian Ilmu Pengetahuan dan Teknologi atau Puspitek. Di kawasan ini pula kemudian dibangun reaktor nuklir serbaguna GA Siwabesi. Reaktor nuklir berkapasitas 30 MW ini merupakan yang terbesar di Asia Tenggara. Sebuah institusi untuk mengembangkan dan mendayagunakan teknologi kemudian juga dapat terimplementasikan dengan pendirian Badan Pengkajian dan Penerapan Teknologi atau BPPT. Pada saat bersamaan, B.J. Habibie juga dilantik menjadi Menteri Negara Riset dan Teknologi, Kepala Badan Pengkajian dan Penerapan Teknologi. Ilmuwan dan negarawan, seperti itulah masyarakat dunia mengenal B.J. Habibie, pakar aeronautika yang sedang berada di puncak karir internasional, namun bersedia kembali untuk membangun negeri. Ia terbukti mampu membawa Indonesia menuju era tinggal landas dengan mengorkestrasi pembangunan di bidang riset dan teknologi. Semangat dan kerja keras untuk selalu menghadirkan inovasi membawa pengabdiannya mencapai posisi puncak di negeri ini. Pemerintah juga sempat mendirikan Dewan Riset Nasional. Melalui lembaga non-struktural ini, digali pemikiran dan pemandangan dari pihak-pihak yang berkepentingan dengan perkembangan iptek di Indonesia. Di tengah derap laju pembangunan, Indonesia masih menyisakan persoalan pada bidang sumber daya manusia. Saat itu, rasio antara insinyur dan penduduk masih terlalu rendah. B.J. Habibie melakukan terobosan dengan menggelar serangkaian program beasiswa ke luar negeri. Program yang sukses dilaksanakan hingga puluhan tahun ini dikelola oleh Pusat Pendidikan dan Latihan BPPT. Pada dekade 80-an, Indonesia mulai banyak mengembangkan industri berbasis teknologi maju. Untuk membangun pola manajemen yang lebih terintegrasi, didirikanlah Badan Pengelola Industri Strategis atau BPIS. BPIS membawahi 10 perusahaan di bidang kedirgantaraan, kemaritiman, metalurgi, transportasi, telekomunikasi, dan elektronika. Pada era Habibie, beberapa hal yang sempat terhenti kembali dibangkitkan, seperti ide lama untuk mendirikan Akademi Ilmu Pengetahuan Indonesia atau IP yang akhirnya dapat terwujud. Kemudian juga dengan dibukanya kembali Lembaga Biologi Molekuler Eijkman yang sempat ditutup pada tahun 60-an. Lembaga yang didirikan ilmuwan Belanda penerima Nobel ini memiliki fokus utama dalam memajukan penelitian dasar dan terapan di bidang biologi molekuler. Puncak keemasan teknologi Indonesia terjadi pada 50 tahun setelah kemerdekaan, tepatnya pada 10 Agustus 1995. Saat pesawat N250 sukses melakukan penerbangan perdana di Bandung. Mengudaranya pesawat yang dirancang dan dibangun sepenuhnya oleh anak bangsa ini menjadi sebuah tonggak sejarah yang kemudian diabadikan sebagai Hari Kebangkitan Teknologi Nasional atau Hakteknas. Memasuki milenia kedua, untuk melompat dan mengejar ketertinggalan dari bangsa lain, terbitlah Undang-Undang Sisnas P3 Iptek. Undang-undang ini menyebutkan kelembagaan ilmu pengetahuan dan teknologi, terdiri atas unsur perguruan tinggi, lembaga penelitian dan pengembangan, badan usaha, dan lembaga penunjang. Sebuah pendekatan untuk meningkatkan kemajuan iptek dengan melibatkan perguruan tinggi sempat dilakukan melalui penggabungan antara Kementerian Riset dan Teknologi dengan Direktorat Jenderal Pendidikan Tinggi. Kemenristek Dikti mewadahi terciptanya inovasi dengan mensinergiskan dunia riset dan dunia kampus. termasuk mendorong hilirisasi hasil riset pada ekosistem industri. 5 tahun berselang, lahir Undang-Undang Sisnas Iptek sebagai pengganti undang-undang yang terbit di tahun 2002. Undang-undang baru ini mengamanatkan pembentukan Badan Riset dan Inovasi Nasional atau BRIN. Badan yang didirikan untuk memastikan ekosistem riset nasional berjalan lebih baik dan maksimal ini ditindaklanjuti dengan Peraturan Presiden tentang pembentukan Kemristek BRIN. Tantangan utama yang langsung dihadapi Kemristek BRIN ialah merebaknya pandemi COVID-19. Sebagai respon, dibentuklah Konsorsium Riset dan Inovasi COVID-19. Fokus utamanya memberikan solusi terhadap wabah, sekaligus meningkatkan kemandirian bangsa melalui kolaborasi dengan berbagai lembaga. Produk inovasi yang hingga kini terus dikembangkan ialah vaksin merah putih. BRIN telah ditetapkan sebagai badan otonom yang bertanggung jawab langsung kepada Presiden. Hal ini dibarengi dengan pelantikan Laksana Tri Handoko sebagai Kepala Badan Riset dan Inovasi Nasional oleh Presiden Joko Widodo. BRIN mengintegrasikan 4 lembaga riset, yaitu LIPI, BPPT, BATA, dan LAPA, termasuk mengkoordinir riset yang dilakukan oleh Litbang Kementerian serta Balitbang daerah di seluruh Indonesia. Keberadaan BRIN diharapkan dapat membuat alur koordinasi riset lebih efektif dan efisien, sebagaimana amanat yang pernah disampaikan Presiden Soekarno tentang lembaga iptek tertinggi di Indonesia.
Excellencies, distinguished guests, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Thank you very much for your coming on the second day of the 4th IEEE Asia Pacific Conference on Geoscience, Electronic and Remote Sensing Technology 2021. I'm Eleonora Gita Alamandasapan.
And I'm Nico Anatoli,
staff of Center for Regional Resources Development of Technology, acting as the Master of Ceremony for this conference.
It is an honor to us to introduce and welcome our speaker for second day of 4th IEEE Asia Pacific Conference on Geoscience, Electronics and Remote Sensing Technology 2021. Profesor Kazuo Ouchi,
Imade Andi Arsana PhD,
Dr. Anindya Wirasatria,
Dr. Yudi Aditya Warman,
Dr. Kunio Yoneyama,
Dr. Dian Nuraini Melati,
Mr. Yudi Anantasena,
and Mr. Michael Wisnuwardana Siagian.
Ladies and gentlemen, we are now continuing to next agenda, that is to hear our speaker, which will be moderated by Dr. Marina. Dr. Marina has more than 20 years of research experience in geoscience. She has been involved in the studies of land cover change from remote sensing instruments to sediment core physical characteristics at ocean depth. She obtained bachelor through doctorate degrees in the United States. She is currently involved in the development of Indonesian National Oceanographic Data Center and a member of the IEEE Ocean Engineering Society.
Ladies and gentlemen, before we start, if you have any question during the presentation from the speaker, use the raise hand button or the question can be delivered via Slido. And please welcome Dr. Marina.
Thank you, Master of Ceremonies, Gita and Nico. Good morning, distinguished speakers and participants of this wonderful second day of our conference, the 2021 IEEE Asia Pacific Conference on Geoscience, Electronics, and Remote Sensing Technology. Today, the second day of our conference, this morning we will have 8 speakers, and let's start from the first one. Sorry, okay. Committee, do I have the? May I share screen? Okay, great. All right. So this morning, I'd like to invite the first speaker. Let me see, let me remove this. Okay. The first speaker is from Japan, Professor Kazuo Ouchi from the Institute of Industrial Science, the University of Tokyo. He will give a presentation titled Oil Slick Detection, Classification, and Tracking by Synthetic Aperture Radar. He received his PhD in Imperial College of Science and Technology in physics. He then worked as a research assistant in the Imperial College, and then the various appointments through the year. And after retirement, he from the National Defense Academy in Japan in 2013. He is a research scientist of the Brain Pool. Let me see, get this guy. The Brain Pool program in the Korea Institute of Ocean Science and Technology, Korea. He is a senior consulting manager in the IHI Corporation, Tokyo, Japan, from 2015 to 2020, and currently he is a senior collaborator with the Institute of Industrial Science, the University of Tokyo, since 2020. His research includes SAR, INSAR, and pulsar system, and applications to land and ocean, EM scattering, and microwave optical remote sensing. To Professor Kazuo Ouchi, I would like to introduce the first presentation, and I would like to invite Professor Kazuo Ouchi to present, to give his speaker. Professor, the time is yours.
Can you hear me? Can you hear me?
Yes, I can hear you.
Oh, good. Okay. Can you see that?
Yes, I can see it.
Okay.
Professor. I think it needs to be in a
slideshow.
Yes.
Come on. Like
Loading.
loading. My computer is rather old.
Yeah.
So I hope it doesn't.
That and the.
Come on.
Don't worry, we're here. We are excited to hear your speak.
Oh, come on. I don't like this. It crash. It may crash.
Would we insist your presentation for?
It's yes, it's still do the. Come on. I think it's crashed. It's crashed.
Committee,
Sorry.
could you help, Professor? Okay, so we are sharing your slideshow, Professor.
Okay, sorry. Yeah.
Right, the time is yours.
Ah, this is the. Okay, you did it.
We did it from here.
Ah, thank you. Okay, how? Good God. What's next?
When you want to the next slide, just let us know, and then we'll do the slides.
Okay.
Yes.
Okay, good morning, everybody. My name is Kazuochi. I'm going to give a brief talk on oil spill detection, classification, and tracking by synthetic aperture radar, SAR. Okay, next, please. Right, contents, background, and radar backscatter from clean and oil-covered surface, radar frequency, and wind speed dependence. Oil slick and lookalikes. Lookalikes are similar to, it appears similar to oil slicks, but they are not. So they are called lookalikes. Methodology, how to classify or detect and classify the oil slicks, that is manual way, intensity-based, polarimetry, and there's popular artificial intelligence. Then movement of oil slick and prediction. Then finally, identifying oil spill sources. Okay, please, next one. I think I can. Could you do the next one? Okay, the top 20 major spills between 1967 to 2020. That's large oil spills from, well, that's 50% of while the ships were underway in open water, among which 58% are collisions and groundings. 90% of collisions and groundings are when the vessels were underway in inland or restricted waters. So these are the major oil spills by ships. Next, please. Okay, synthetic aperture radar versus optical sensors. Now, these are the images of optical and SAR taken by simultaneously taken by aero satellites, that's in Tokyo Bay, Japan. And you can see the Eros optical image, a lot of cloud here, but Eros pulsar, you can see the without cloud. Next, please. Come on, next. Next. Next, please. Shall I load my?
I think the Wi-Fi in here also. Yeah, maybe we can wait a little bit.
Shall I load again? Okay. Types of oil examples that that's a natural oil seep, and from the bottom of sea, the sort of coming out naturally, and possibly there is a sort of well, oil well underneath, and crude oil, mineral oil, and the immersion. That's a mixture of oil and water. Next, please. The sources of oil slicks are, well, accidents and collisions. That's in Korea. And that's a naughty ship. It's discharging the waste oil here. And oil wells there, a natural oil seep. Okay, next, please. That's a principle of oil slick detection. Now, when the oil slick is on the surface of the sea water, then it dumps the small-scale surface roughness. So when the radio wave is incident on the surface, it's reflected by the specular direction because it's mirror-like, very smooth. On the other hand, the surface without oil slick is there's a small-scale surface roughness, so you get some radar backscatter. So it appears bright, while oil slick area becomes dark. Next, please. Okay, frequency dependence, wavelength dependence. Now, the oil slick, for the case of oil slick surface, it's more X band, L band, C band is the same. You don't get much backscatter, it appears dark. But X band and C band, the effective surface roughness is large and larger than the L band effective surface roughness. So you get a strong radar backscatter from clean sea surface at X band and C band, but a little from L band. So back image appears as oil slick dark, but X and C band rather bright, and slightly dark here at L band. Example, next please. This example, oil slick, it's a controlled experiment. You can see this is X band oil slick here, and that's L band. You can see X band images are much higher contrast. Next, please. Wind dependence. Okay, wind speed suitable for oil slick detection is around 2 to 3 meters per sec to 10 to 14 meters per sec. Now it depends on the types of oil. Light natural oil and heavy crude oil, slightly different. Now under weak or no wind, both the sea surface and oil-covered surface are very smooth. So you don't get much backscatter from sea surface and oil slick surface. So it appears equally dark. Next, please. If the wind is very strong, then both the sea surface and oil-covered surface become equally rough, very rough. So you get, well, lots of evaporation and dissolution, dispersion, and the damping effect is very small, negligible. So we get, well, more or less the same radar backscatter from the oil-covered surface and the smooth non-oil surface. So it appears equally bright. Next, please. Now that's the lookalikes. Lookalikes are similar, appear similar like this to oil slick area. But so it comes from biologic low wind areas here and biogenic natural film here. So that's a biogenic film which damps surface roughness compared to the clean surface. And that's atmospheric internal waves. And upwelling is here. Upwelling is water coming out from the bottom. That's upwelling. And it appears dark, it becomes very smooth. And other effects are like shipwrecks and so on. Okay, next, please. So how to detect and classify. Now, manual approach. Just classification is by trained operators, and detection accuracy, depending on the operator skill. And single polarization intensity analysis, the image classifiers such as histogram thresholding and classification of oil and lookalikes is based on the brightness of the image and the shape. It has more entropy and the interpolarization correlation and all other things. It's accurate, but the physical reasons why the polarimetric classifier is so good are not well validated. And polarimetric mode in synthetic capture radar in spacecraft is not routinely operational. Now, artificial intelligence and machine learning. Now, it can be used to single polarization and polarimetric data. Early versions of supervised classifiers such as support vector machine, neural network, and so on. Now, it's very accurate, but requires a large number of training data. Next, please. That's the manual approach. Now, the operator is here looking at the screen and from his eye, and also supporting external information such as ships, with and without AIS. AIS is the signal transmitted by ships, giving the information about the ship's names, where it's going, and so on. And the location of oil rigs, coastlines, and so on. Now, they supporting external information and looking at the image of the synthetic capture radar, this operator decides whether this is a oil slick or not. So accuracy depends on the operator's skill. Next, please. Now, the single polarization intensity image, the amount of reduction in image intensity when the oil slick appears, then mineral oil is about 3 dB, minus 3 dB difference there, while the biogenic film is 10 dB. Now, crude oil is 9.3 dB, immersion 8.3. It's also, usually reduction by mineral oil films is smaller than the biogenic films. So from this intensity, intensity difference, possibly we can classify the oil slicks. The amount of reduction depends on, of course, the radar wavelength and the incidence angle, and also the wind speed. And the other way of detection is image shapes, like this one. That's a natural shape. It's a characteristics of the shape. And of course, this ship releasing, dumping this oil. So from image shapes, we can classify the oil. And others include texture analysis, statistical analysis, and machine learning. Next, please. Okay, this is supposed to be moving. Well, polarimetry. Next, please. Okay, the polarimetry is based upon the 3 different kinds of polarization data. And one of them is scattering power decomposition. That is a backscatter signal is divided, classified, or decomposed into 4 different contributions like single bands, double bands, volume scattering, and helix. Helix scattering is a linearly polarized incidence wave is changed into circular polarization. Now, entropy describes the randomness of the return signal or image itself. And alpha angle, single bands to double band scattering processes, and others as well. Okay, next, please. Now, that's an example, again, is a controlled experiment of oil slick detection using RadarSat-2 synthetic capture radar data. Now, they used the plant oil, immersion, and crude oil. They are released, and the images are taken. And this is a plant oil here, and immersion is here, crude oil is here. Okay, then, okay, next, please. They used, that's the intensity image in plant oil, immersion, crude oil. They looked at the entropy randomness of the backscatter signal, randomness. Alpha angle, that the scattering process is different. Well, supposed to be different. And that's a classification result. Please, next, please. Now, you see the radar backscatter from sea surface is just a single band scattering, single band surface scattering with and without oil slick. The polarimetry is based on different scattering processes, entropy, alpha, angle, and so on. But again, you see the single band, only single band scattering from the sea surface. So the differences in these entropy and alpha angle must be associated with system noise and dielectric constants of seawater or possibly oil thickness. So if the image is very dark, return signal is dark, sea surface, well, compared to the sea surface level, that's a system noise here. Plant oil level, plant oil here, it's not, well, it's almost the system noise level. So you got some sort of randomness there, which means high entropy. Even higher entropy is immersion, because immersion image itself, the backscatter is very weak. Even weaker is crude oil here, and it has a lot of randomness from system noise. So the entropy is very large. Okay, next, please. Next is the artificial intelligence. It's very popular these days, and people are using it. I don't particularly like it because it's in black box. You don't know what's going on inside this hidden layers. But, well, it requires a large number of data to train the system. Training data should contain the parameters and features effectively characterize the targets to be classified. This is a convolution neural network input layer, multiple layers of hidden layers, the output layers. Next, please. This is an example of, you see that training data is 183 oil spots, 720 lookalikes. That's, they use this data set, and well, that's the input data here, train, and this artificial neural network they used. And they compared with ASR, image ANN, adaptive threshold, edge detection, and so on. Now, other, well, next, please. Okay, they classified well using AI, detected oil slip, detected lookalikes. Now, accuracy, oil detection accuracy is nearly 92%. Lookalikes, very accurate, 98%. Overall accuracy is 94%. That's a confusion matrix. Now, recent reports using the polarimetric data given by these people here. Next, please. Okay, this is supposed to be moving, you see. Well, this is the Mediterranean Sea, and oil spill from a collision between cargo and tanker. And well, in this is supposed to be moving in a different way, see. But anyway, that's the oil spill areas change here to their depending on the ocean current and wind. Next, please. The way to do it, the prediction forward model, that is, uses the empirical diffusion equation, like that's the oil vector, movement vector, the current vector plus wind vector times, that's Q. Q is the wind drift factor. That's empirically decided. That's IMO, and most of the institutes are using 0.03. They are a good choice. Now, ocean wind, current tide, and they go into this diffusion model, SAR image, oil particle extraction. That's I'm going to show you in a minute. The oil particle image, then estimation of oil diffusion by tracking the oil particle. Next, please. What is oil particle? It's just a virtual oil particles, which is divided. This image here is gridded cell image here. And then each cell here is virtual oil particles. Well, this one doesn't have, this particles doesn't have what? Oil, but this has oil particles. So this oil particles are chased using a diffusion model, okay? At time 1 and next time 2. Then this probably, this one moved here. This particle moved here. Then we decide what next, the oil particle, oil spills in time 2. Next, please. This is a case of oil heavy spirit accident in Korea. And we used such as a previous system. And next, please. Yeah, well, that's the simulation SAR data here. Now, it's very similar. Well, there's supposed to be few images here, but well, because of the PDF, you can't show it. Its wind factor is 0.03. Okay, we published this here in this paper. Next, please. Okay, you can then reverse the oil spill before the time of SAR data acquisition. For instance, we received the SAR data at T1, and we have SAR image here. But using the same system, diffusion model, then we track back where the before time T or time T2, where the oil slicks are. Then probably we can reverse to the position where the oil slick started. That's an example of that previous heavy spirit case. And well, it's not that 70% accurate, something like that. Anyway, it's published here. Okay, next, please. Now, where the oil spill is coming from, identifying sources. Now, that's like, well, I explained using a diffusion model, track back. Now, next one is from SAR images of stationary sources. That's oil rigs, wrecked ships, like this one. That's Deepwater Horizon. And oil rigs, we know where the oil rigs are, so the oils are coming out of these rigs. And natural seeps are very characteristic shapes here. So we can find out, identify the sources of oil spill. Next, please.
2 more minutes.
Okay.
Please, Professor.
Okay, this is a case for using AIS. And SAR image, okay, here. And that's the AIS where the ship is transmitting where it is, like this. So this ship is releasing the waste oil here. So we can identify the source of this oil responsible, this ship, using AIS like this one. Next, please. So that's the classification, oil slick classification detection, and that's a summary. Yeah. Okay, next, please. The good news is that, well, over the last 50 years, the statistics of oil spills greater than 7 tons from tankers show a marked downward trend like this. So that's a good news. Okay, next, please. Thank you for listening. And I'm sorry for the my system that I could not do this.
It's okay. All right. Thank you very much, Professor Kazuo, for this very interesting update or new technologies, new processing methods for detecting oil spill. My note is that the SAR method may distinguish between various oil spills, the plant oil, emulsion, or crude oil. And then using the new method of artificial neural network gives good accuracy. and also the model for predicting the movement of the oil spill is very interesting.
Good.
Thank you very much, Professor.
Thank you.
I would like to remind the participants, and if you have any question, you may write in the Slido that's available, the link in the chat. Okay. Next, I would like to, okay, let me find. All right. I would like to go to the next distinguished speaker. The next one is Imade Andi Arsana, PhD from the Gajah Mada University. And his presentation today is titled Towards Geomaritime Security 4.0 in Indonesia. Opportunities and challenges in geospatial technology application in maritime security. Okay. Dr. Imade Andi Arsana obtained his PhD from the Australian National Centre for Ocean Resources and Security in Australia. He is currently a lecturer and researcher at the Department of Geodetic Engineering, University of Gajah Mada. He has many experiences. For example, since 2017, he has been appointed by the Indonesian Ministry of Foreign Affairs as an expert of the technical theme of maritime boundary delimitation between Indonesia and its neighboring countries. He has many achievements, and for his achievement, he is popular in publication and has received various awards from Australia, France, Germany, Netherlands, and Indonesia. Now I would like to invite Imade Andi Arsana, PhD, to present your presentation. The time is yours. Let me.
Thank you very much, Mariana, for the introduction. I hope you can hear my voice.
Yes, I can hear you. Thank you.
Thank you very much. Allow me to share my PowerPoint now. Ladies and gentlemen, I would like to first thank the organizer for this invitation. It's an honor to be sharing the stage with prominent speakers and also researchers from all over the world. Thank you very much. I really enjoyed the presentation we just had a few minutes ago. Thank you very much, Professor. Towards Geomaritime Security 4.0 in Indonesia, that is my idea today. First of all, I would like to bring you to several cases that Indonesia has been facing so far. If you Indonesian and follow the news recently, for example, on the April, a couple of months ago, there are 5 Vietnamese fishing boats captured by Indonesian patrolling officer for the accusation that they stole squids in the North Natuna Sea. That is one thing, that is illegal fishing like this happens from time to time in Indonesia. I think this is something that we are facing at the moment in terms of maritime security and ocean issues in Indonesia. We also heard, for example, a few days ago, a Chinese survey ship actually lingering in EEZ of Indonesia, that this poses a dilemma for Indonesia. The case in the South China Sea, I think, is something that Indonesia has been focusing so far, and the news is everywhere. So now the question is, what can we do about that, and what happens actually, legally speaking, and how can technology help? If I can demonstrate to you in one slide what problems that we face in Indonesia regarding the ocean management, here's how I will inform you. First, Indonesia is an archipelagic state, which means that it is legal for us to have or to secure the ocean in between our islands. And beyond that, we have 12 nautical miles of territorial sea, and then 24 nautical miles of contiguous zone, and also EEZ. And beyond that, we have continental shelf. So this is based on the Law of the Sea Convention, and the complexity is already there. How can we define our maritime zone? That is first issue. The second will be the passage and navigation. So how can foreign vessel navigate through our waters or Indonesian waters, and how they should behave, and what can we do, what cannot we do about that? So this is something that bringing complexity also in the ocean management in Indonesia. The next one is that if we have, because we are not alone in the ocean, we have neighbors. They also are entitled to 12, 24, and 200, and that creates overlapping claim or overlapping entitlement over here that generates or require a maritime boundary delimitation. So that is our next homework in Indonesia, to delimit or to define borders with our neighboring countries, which is, in this case, we have 10 neighbors. To deal with one neighbor is already quite complex. Now we have 10 neighbors. This is another example. We also deal with the extended continental shelf. So continental shelf beyond 200 nautical miles that we need to submit to the UN CLCS, for example. So in addition to that, it is possible for us to have other countries as our neighbors. For example, in the north of Papua, we might have Federated State of Micronesia to be a neighbor. So we need to deal with them in terms of maritime boundary delimitation. We also have small islands to deal with. We have a lot in Indonesia, and that complexity will be bigger when the small islands actually belong to other countries, but it's close to our country, like Christmas Island, for example, in the south of Java. So that actually generate or require us to delimit our borders also with that. And this is called the issue of enclave or semi-enclave maritime boundaries. The other issue is we have other countries that is actually not legally having overlapping claim with us, but that particular country can claim or propose that claim a lot beyond what it is actually entitled based on law of designation, and it generates maritime dispute, which is actually wrong. So in this case, there will be resources competition between us and other countries. We talk also about how geospatial method and technology can help us deal with this issue. And certainly we talk about sovereignty and sovereign rights. So in one slide, this is the complexity of issues in ocean management in Indonesia. Now, if we bring that into the context of Indonesia, first is that we have to define borders with 10 neighbors from India, Thailand, Malaysia, Singapore, Vietnam. We have Philippines, Palau, Papua New Guinea, Australia, and Timor-Leste. So in here, for example, what we have already is, for example, in the west of Sumatra, we have our own unilateral claim. We don't need to deal with anyone because there is no countries over here, so it's all good. But in here, for example, we have delimited boundaries with Australia. In this case, it's Christmas Island. With Australia is over here. So the red one is actually the borders that we already settled with our neighbors. We also have this blue dashed line, which is actually our claim borders. So it is not an agreed borders, for example, between Indonesia and Palau. This is what we wanted, but this is what Palau wanted, different line. So meaning that there are lines that we already agreed. There are a lot of lines that we haven't agreed with our neighbors. But on the other hand, we already studied the management of our fish, for example. So can you imagine the complexity? We haven't really settled the borders yet, but we have to manage the area, including how to deal with fish, for example. So that's the complexity. Now, if you see other complexity, for example, there's a case where maritime boundaries of continental shelf or the seabed already settled, but the water column is not yet settled. So this is an example between Indonesia and Vietnam, or Indonesia and Malaysia. We have settled our seabed boundaries, but we haven't settled our water boundaries yet, water column. And Indonesia wanted the water column to be different from the seabed boundaries. This is almost always the case, where our neighbors always want the boundaries to be in the same line as the seabed boundaries, which means there are no different interpretation or different proposal here, where Indonesia wants this purple, where other countries want this green, for example. So there will be overlapping claim over there. For example, between Indonesia and Malaysia, Indonesia and Vietnam. So can you imagine if there's a fishing vessel or boat over there, and we will basically judge that actually in violation to the borders. But the same thing will goes to also Indonesian fishermen. If they go there, and they will be just say that this is also a violation to borders. Good things or maybe interesting things might take place when the patrolling officers of two countries will meet in that particular gray area. So what can we do about this? So we can say you entered our water, and they will say the same sentence, you are the one entered our water, because this is actually a different interpretation or different proposal. So this happens a lot in Indonesia, between Indonesia and Malaysia, Indonesia and Vietnam. If you see what happens during the incidents in the South China Sea, this is actually one of the examples how it takes place. Now you might ask the question, is it possible actually for two countries to have borders for the seabed different from the borders for the water column, which is like this? The answer is yes, it is possible, and we have already settled such kind of arrangement with Australia. So back in the 1970s, we already settled our borders with Australia, which is the seabed. And in 1997, we settled another borders for the water column, which is different from that seabed line. Now from this, you can imagine there will be space over there where the seabed belongs to Australia, but the water column belongs to Indonesia, which I know that this can be very complex, but this is real and this is legal. So even though this is complex, it is actually acceptable by the law. Now, can you imagine in this particular space, so the water belongs to Indonesia, which means the fish belong to Indonesia. If I may joke about that, the fish might have that passport with the Garuda Pancasila on it. Even though we know that the fish does not have passport or they don't have a nationality, but at least we are aware at that particular space, we can fish, okay? We can fish. However, we understand also in that particular space, we cannot really do the oil and gas drilling because that belongs to Australia. But what you might not be aware of is that the sedentary species like sea cucumber actually belongs to Australia. Why? Because that particular species attached to the seabed, because the seabed belongs to Australia. Now, can you imagine our fishermen would understand that they can go there and fish, but if they accidentally catch sea cucumber, they actually, it's a violation to the international law. So this complexity requires some solution, some technical solution for our fishermen also. Now, the South China Sea, I think everybody heard this somehow from different perspective, different field of studies, but allow me to show you how we understand this, how I understand this from the geospatial perspective. So Indonesia in the South China Sea actually has nothing to do with this disputed islands, which is called Spratly Islands, because we don't claim it, we don't claim anything, and nobody claim the islands that belong to Indonesia. So we don't really have any sovereignty dispute in the South China Sea. We have to be clear about this. So that's why Indonesia claims itself as a non-claimant state, which is a state that does not really claim anything in the South China Sea in terms of islands or rock or low tide elevation. However, certainly Indonesia is entitled to ocean over here based on the law of the Sea Convention, because it is entitled to 200 nautical miles of territorial sea and so on and so forth. So what happens in the South China Sea is that Indonesia has borders with Malaysia and Vietnam and already settled the seabed borders with Malaysia in 1969 and in 2003 with Vietnam. So in terms of seabed boundaries, it's all settled already. So it is clear now which seabed belongs to Indonesia. So we don't have any issue with the seabed in the South China Sea. The issue that we have is actually for the water column, which is exclusive economic zone. So this is the 200 nautical miles from Vietnam. This is just the simulation based on the law. This is 200 nautical miles from Malaysia, Brunei, and Philippines. And this is 200 nautical miles from Indonesia. So now you can clearly see, based on the law of the Sea Convention, there are overlapping entitlement of that. So we need to deal with that, right? So this is what Vietnam proposed. This is what Indonesia proposed, which is different, of course, and that generates overlapping area over there. So if you go there to fish for Indonesia, for example, and Vietnam will say that, hey, you come to our water, and the other way around. From that Chinese perspective, if you see this, so this is actually the one based on the law of the Sea Convention, but China has a different idea. So they propose this, we call it 9-dash line, which actually cover almost the entire of the South China Sea. So it is not based on the law of the sea convention. It is based on what they call as a traditional fishing ground. So now can you imagine if we use a different base or different law in claiming waters around there? So it is not surprising that there will be overlapping or messy overlapping claim over there. Right? The thing is that, so this, according to China, belongs to China, this shaded area, which is actually, once again, it is not based on the law of the sea convention. And of course, a lot of people are actually, if I may say, offended, or they didn't really agree with what China claimed. But once again, this is the complexity. And based on the latest decision made by the Permanent Court of Arbitration, actually, the 9-dash line was considered as baseless in terms of law. So it's not supposed to be there. So actually, basically, the court decided that China does not really have any legal basis to claim the 9-dash line. However, that is the decision of the court, but China has a different view. They think that they keep maintaining those lines and those actually area. And then that's so I'm not trying to take side or whatever here. I just want to show you the reality, the complexity in it. And we are not here to judge which one is wrong, which one is right. But this is actually the fact what happened. So it means that if China then came to us, either survey vessel or fishing, now at least we understand they came there because they are sure that this area actually belongs to them, even though legally speaking, it is still disputed. All right, that is actually the complexity that we have now around Indonesia. Now, how geospatial technology can help that maritime security actually to be better? I won't really explain this to you because I think most of you, or even all of you, understand what Industrial Revolution 4.0 is all about. I just would like to show you this very typical picture that you probably have seen maybe hundreds of times. But let us talk about the big data. We heard from the previous speakers. Thank you very much for those very detailed explanation. I'm not going to be that detailed, but basically we imagine our water like this, which is quite peaceful and sepi and quiet, but it is not actually. In fact, if we check the marinetraffic.com, it looks like this. Very messy, very crowded, with a lot of fishing vessel over there. So with that, we actually have a lot of data, right? So we consider that as a big data, and we try to make sense of that. And the behavior of people, behavior of vessel, and all those things, we can actually predict, or we can actually have a good forecast about what happens, because we have a lot of data, right? So that's how I imagine the utilization of big data analytics in this case, how to predict the behavior of a vessel. And so we can then do the law enforcement better because we understand better the behavior of those vessels. So I'm not, what I'm trying to say here is that what they are doing is not illegal, because it is by law that they can actually come to Indonesia to go through, to navigate, but not to fish. They are wrong only if they fish or they don't really comply with the law of the sea convention. So it is, I'm trying to basically confirm here that it is wrong if we think that the foreign vessel cannot really go through our waters. That is basically something that a lot of people misunderstand. Second is about IoT. I don't want to explain this a lot, but I think most of you understand this better than I do, that how we try to utilize different objects, different points, different units, and they communicate each other. We call it the IoT. I think you understand what IoT is all about, and how can we maximize this in order for us to understand better what happens on the ocean and things like that. Cloud, this is obvious. Everybody now, everyone use cloud now to store things. So now we see.
2 more minutes, please.
Thank you so much. So we basically will be able to utilize other resources that store in the cloud for the purpose of the ocean management. Cognitive computing, as I said earlier, we understand better the behavior of people or vessels conducting operation on the ocean, and that will make us or help us actually to bring a better decision in order for us to manage our ocean in a more effective way. So for the concluding remarks, I would like to once again highlight this. Indonesia is large, that's quite obvious. Large means opportunities and complexities are there. So issues and also opportunities for research are there. Maritime security does matter. We covered it already. And pending maritime security issues is, first, we have maritime boundaries to deal with, and we have resource management to also to take care of. And geomaritime security, which is the utilization of geospatial technology, is one that I have already proposed. It is not a very specific ideas as yet, but I think this is just to give us a better opening ideas how we can utilize geoinformation and geospatial technology in maritime security. With that, I thank you very much. Matur nuwun.
Thank you very much, Dr. Imade Arsana. It's very interesting. I guess it's the insight for the complexity of management of our island nation. We have 14,000 islands. It's very complex then.
Right.
And you also gave a solution for to manage these complexities by presenting the geomarine security. So thank you very much. Again, I would like to remind the participants to, if you have any questions, to please write your questions in the Slido. The link is available in the chat. Okay. All right, I would like to go to the next presenter. Let me share. Okay. Our next speaker. Oh, okay. Our next speaker is Dr. Anindya Wirasatria. He is from the University of Diponegoro. The title of the, let me see, open this. The title of his presentation this morning is The Variability of Upwelling Within the Indonesian Seas Revealed by the Satellite Data. Dr. Anindya received his Doctors of Science from Tohoku University in Japan, and also his master's degree. He is now Secretary of the Oceanography Department, Faculty of Fishery and Marine Science. Among the various, okay, I'm sorry, that's my alarm. Among the various appointments that he has from the Diponegoro University, he has accomplished writing. He produced 15 papers. Publication in reputed international journal for the past 5 years. So I would like to invite Dr. Anindya Wirasatria to give your presentation. Dr. Anindya, the time is yours.
Okay, thank you very much, Dr. Marina, for the chance. First of all, I would like to thank to the committee, especially for the Dr. Iqbal, that have invited me in this very variable meeting. So today I would like to share the works that have been done within, I think, 5 years. Yeah. Can you see my screen?
Yes.
Okay.
Clear. Yes.
So I should go it very fast because I have many slides here. So in this sense, I would like to present the variability of the upwelling within the Indonesian seas using remote sensing approach. So this is the layout of my presentation. First, I would like to explain what is upwelling, and then how is upwelling generated, and why do we need this to study the upwelling. And the last one is, which is the main event, is the variability of upwelling within the Indonesian seas. So what is upwelling? Upwelling is the water mass lifting from the deeper water column to the upper layer, on the sea surface, which is known as upwelling. This lifted water mass bring cold water, which is cool sea surface, and nutrient-rich water, which is favorable for phytoplankton growth. So the lower sea surface temperature and higher sea surface chlorophyll concentration are often used as an indicator of an upwelling event. So because of the sea surface condition indicates the occurrence of the upwelling, so satellite observation, which is measuring the surface condition, is powerful tools for investigating the upwelling. So how is upwelling generated? The generation of upwelling cannot be separated with this Ekman current. Yeah. So if the wind blows above the sea surface, so it will generate current. The current which is not in the same direction with the wind direction. So it will be deflected about 90 degree in a degree in the right side of the wind in the northern hemisphere and the left side of the wind in the southern hemisphere. This is due to the balancing between the wind stress and also the Coriolis effect. Yeah. So what happens if it occurs in the equatorial region? So if like for example like this is the trade wind. So in the if the trade wind comes in the from the easterly winds, yeah. So in the northern hemisphere, it will deflect it on the right, and this is on the left, and it will make a divergent current like this. So in the equatorial region, it will be loss of water mass, and then it will be replaced by the water mass from the deeper column, and that's why it can generate upwelling. This is the very clear evidence. Yeah, this is the chlorophyll concentration. So we can see that during in the equator region in the Pacific, there is a very high chlorophyll A concentration in the equatorial region due to the equatorial upwelling. Yeah. And then in the coastal area, it also can generate upwelling, which is called by the coastal upwelling. If the wind blows along the coastal line, and then the Ekman transport will be moved away to the seaside, and then it also will generate the upwelling, because this area will be the loss of water mass in the along the coastal line will be replaced by the water mass from the deeper layer. And then why do we need to study about the upwelling? The lifted water mass bring cold water which cool the surface and nutrient rich water which is favorable for phytoplankton growth. Yeah. So if we see in the upwelling region, there is a very high chlorophyll A and also sea surface temperature. And based on many studies, yeah, this just has the positive correlation between the fishes productivity and the upwelling occurrence. As shown in this figure, for example, this is the chlorophyll A. This is the catch of the Catsurus pelamis in the South Sea. Yeah. So we can see very clearly that if the chlorophyll high increase, so the catch will also increase. Conversely, for the surface temperature, if the temperature decrease, so the if the temperature decrease, so the catch also increase. And this is the other example in the Indian Ocean. This is the tuna catch. So the color means the colors dot mean the higher catch. Yeah. So if we see in the graph, so the lower temperature, the higher chlorophyll A, so more colorful dot in this region. So the study of upwelling will play an important role for the fisheries management in an area. Yeah. And this one is the variability of upwelling within the Indonesian seas, which is the main topic of this presentation. So I will Actually, many study about the upwelling during Indonesian seas, but I will only highlight 3 cases. The first is I would like to highlight the series stories of the upwelling at the Maluku Sea. The story began with this paper done by the Setiawan and Habibie in 2011. So they managed to detect the chlorophyll A bloom in the Gulf of Tomini. So Tomini Bay is very, very important. It supports the major biodiversity and also heavy fishing. But because of the lack of the in situ measurement, so the oceanographic condition in this area is less studies. So they provide the first evidence for the occurrence of chlorophyll bloom in the Gulf of Tomini tip during summer monsoon by using the satellite data. This is the result. So this is the chlorophyll, this is the surface temperature, and this is the wind. So we can see here very clearly, this is the climatological average. So average for about 10 years period of observation, yeah. In June, July, August. So from June, we can see that the chlorophyll A in this area is still not so much, and then increasing and peak in August. This is in accordance with the cooling of the sea surface, which is also peak in August. This is also correspond to the wind speed. Yeah. So during the August, there is a peak of wind speed which is come out from this wind cap. Yeah, wind cap. So the higher wind speed here will tend to decrease the SST and also increase the chlorophyll A, and the lowering wind speed will increase the SST and decrease the chlorophyll A. And this only occur during the summertime or southeast monsoon season. Because during the winter monsoon, we can see here, there is no signal for the chlorophyll A blooming and also SST cooling because the wind speed is low. Yeah. And then later on in 2017, I tried to investigate the effect of ENSO. It's my paper in the IEEE. And then this one, my motivation is like this, my background. Yeah, because even though in August, there is a peak of the chlorophyll A blooming, but if we make a standard deviation map, it also variable. Yeah. So in August, although it's the peak, but sometimes the peak is very high, but sometimes it's not so high. Yeah. So high standard deviation in here means the high internal variation. So strongest internal variation in Indonesian is driven by ENSO. So in this study, I would like to investigate the ENSO effect on the variability of chlorophyll A and SST in the Maluku Sea. So what I did is just I make a composite, I make an average, yeah, for the El Nino case and also La Nina case within maybe 12 years, yeah, 12 years. So this one is the composite of the El Nino in August, which is we have 3 cases and also 3 cases for La Nina. And this one is the result. We can see here, this is the climatology in August, and this is the El Nino, this is the La Nina, this is the chlorophyll, SST, and this is the wind speed. So this very clearly, during the El Nino, this is the anomaly of El Nino, the surface chlorophyll is higher than the climatology, and during La Nina, surface chlorophyll is lower. Yeah, and then for the surface temperature is lower, but during La Nina is higher. Why? Because the wind speed is higher in during the El Nino and lower during the La Nina. And if we extract the value in this box, we can see here, this is the chlorophyll A. El Nino is higher than the La Nina, and El Nino and normal is in the middle. Yeah. and this is also the SST. SST in the El Nino is lower. This is the La Nina, and this is in the middle. The wind speed, this is El Nino, this is La Nina, and this is the normal condition. So in here, it is very clearly evident that the El Nino tend to increase chlorophyll A, reduce SST due to the increase of the southerly wind speed, and La Nina tends to reduce chlorophyll A, increase SST due to the reduction of the southerly wind speed. And how the ENSOMO define the upwelling in this area? Here I plot the SLP, the sea level pressure, and also the vertical wind, vertical wind. During the La Nina, Malakusi become the convection area, which lowering pressure gradient. This is La Nina. So the blue means the convection, means the there is a moving upward, the moving upward, and then which lowering the pressure gradient and reducing wind speed. And during El Nino, Malakusi become subsidence area. Here, Malakusi become the subsidence area, become orange, which increase pressure gradient and accelerating wind speed. And then this work is continued by the Sari et al. In 2018, because in my study I didn't consider about the IOD. So in this study they consider about the IOD. The result is like this. So they investigate many map like this, and then they conclude that high surface chlorophyll A concentration was observed during El Nino and positive or positive IOD event, and the situation was reversed during the La Nina and or negative IOD event. And then it's continued also by the Atmat Bureau et al. 2018. So they investigated the upwelling characteristic during the El Nino 2015 in the Maluku Sea. Previous upwelling study in this region have only provided simplified physical mechanism analysis and only focused on the surface feature of upwelling. The objective of this study is to investigate physical processes and dynamics of upwelling, particularly change in the ocean atmospheric variables before, during, after upwelling, mechanism of upwelling generating force during the 2015 Super El Nino event, and to analyze the internal variation of upwelling intensity related to ENSO between 2008 and 2015. So in these figures, we can see here that actually this is in the southern hemisphere. So if the wind speed, if the wind comes from the south, in the southern hemisphere, it should be if we consider about the Ekman theory, so the wind will be the current will be deflected to the right and the left. So it should be actually the downwelling, not upwelling. So this is, but we can see in the previous presentation that there is a very strong evidence of upwelling in this area, which is indicated by the high chlorophyll A and low sea surface temperature. So it could be wrong, the Ekman theory. So we will discuss later. So they use the model data, Indisio model, the model produced by the KKP, I think, and they already validate this model with the satellite data. So we can see that there is a good agreement between the model and the satellite data, and then they can use this model. And this is the current factor and also the sea surface temperature, in the 25-meter depth. We can see here that during August, there is a northward direction of the sea surface of the current, which can decrease the sea surface temperature. So because of the surface current move to the north, so there is a loss, water mass loss, because of the this current, and then the water mass loss is replaced by the deeper water mass, which is colder. And this is the evidence of the lifting water mass, we can see here that this is the graph showing this line, this yellow line. So during wet monsoon, there is no lifting water mass, but during southeast monsoon, we can see here that there is a cold water mass lifting, from the depth to the sea surface, which indicated the upwelling. This is the upwelling of the evidence of upwelling. And then this is also the
4 more minutes,
vertical
please.
section. Oh, okay. Vertical section of this graph. We can see here there is a not what movement of this cap, so which can cause the upwelling. So the fully developed submonsoon wind tracking surface water, not what, similar to the wind direction, since the effect of coriolis vanished near the equator. So because this is near equator, so the current generated by the wind is the same direction with the wind. And this is the paper that I try to continue. So I investigate the district characteristic of SST variabilities in the Sulawesi Sea and the north part of Maluku Sea. So this is already well known, this one, in this area, in the upwelling, but no one tried to continue the analysis of this wind, the trajectory of the wind. So I try to investigate more in this area and in this area because I found that there is a very interesting phenomena. In the Sulawesi Sea, the temperature is very, very high, and in the Maluku Sea, the temperature is low in the August. So there is a contrast temperature, even though there is in this area is not so far. So in this graph, I can show you that this area is very low wind speed. That's why this is very, very high temperature, and this is a very strong wind speed. So this is a very, very low. But in this particular area, in the middle of this Sulawesi Sea, we can see there is a wind cap here. So the temperature is not so high as the adjacent water. So we can see here that the comparing this blue area and the green area, we can see clearly that the relation between wind speed and SST, the SST of the wind speed in the both area is almost the same actually, wind speed. And the maximum is this is until 8 and 6, and this is until 7. 7. But the decreasing SST is different. And if we see here in this graph, we can see that latent heat release have more influence in the green box than in the blue box. But why the decreasing temperature is more in the blue box? So the answer is because of the Ekman transport. We can see here the seaward Ekman transport actually is more dominant than the latent heat release in the both side. That's why in the blue area, the decreasing temperature is more than the green box because the seaward Ekman transport is more than the green box. And then I have 1 minute or 2 minutes.
Less than 1 minute, if you can do the
Less than 1 minute,
conclusion,
so
please.
I will skip this.
Very sorry.
Okay. And then the last one is the northwest monsoon upwelling between the Indonesian seas. So this is the summary of upwelling. So because most of the upwelling studies in the Indonesian Sea is focused on the southeast monsoon session. So I try to investigate the in the northwest monsoon. So this one is the northwest monsoon wind. Yeah. So in the considering the element theory along the northern of Java, Sunda Island to Sunda Island, may potential from the coastal upwelling area. This one, and then I can see the upwelling signal. This is the chlorophyll A. This is the anomaly of SST. This is the SLA. Yeah. So I will skip this. But actually, in this area, in the north and the South China Sea and the Java Sea, the upwelling is not clear because the chlorophyll A measurement by satellite is contaminated with the suspended sediment. That's why in this area, actually only Lesser Sunda Island has strong indication of northward monsoon upwelling. The other area is in this area, in the Malacca Strait, and also in the northern part of Papua.
I'm sorry, the time is finished.
Okay, finished. So this is the summary of upwelling in the Indonesian Sea. So in the blue color is the southeast monsoon upwelling, and the red color is the northwest monsoon upwelling. So thank you very much for your kind attention. Sorry for the very fast presentation.
Okay, thank you, Dr. Anindya, for this very interesting study and well covered presentation of upwelling in Indonesia. It's very interesting. Thank you very much. Next, we are in the question and answer session. And I have the committee have sent me several questions. Each for the speaker. Okay, maybe I'd like to ask the committee, do the speakers may read the questions in Slido or not? Okay, maybe, all right. So because of the time constraint, I apologize that I will ask one question per speaker, and the other question will be shown by the committee to in the chat box. Or maybe the speaker may access the Slido and then type in the answers over there. Okay, I apologize for that inconvenience. So for Professor Kazuo Ouchi,
yes,
there are 3 questions.
Wow.
But I will only ask one of them because of time constraint.
Okay.
All right. So for the first time. As you mentioned in your presentation, the concept of Snell's law was implemented on SAR. Do you agree if the density affected the degree of polarization? This question is from Mr. Fadli.
Yes, I think it's density or thickness damps the sea surface much more than the others. So thickness may be important. At the moment, there isn't enough reports or study on the thickness and the direct constant yet. But I think that the thickness, and it's something similar to the types of oil. Heavy oil dumps the surface roughness more than the other plant oil. So the reduction in return signal, backscatter signal, is larger than the others. So which means that you get more random system noise. That's probably the reason why for the heavy oil has a different polarization signature. Did I answer?
Yes, I think so. Thank you very much, Professor.
Yeah.
Okay, the next question is for Dr. Arsana. Okay, the question is, will the issue of the North Natuna Sea overlapping with China's 9-dash line for a long time? This question is from Mr. Perdana.
Thank you very much. It's a $1 billion question. It's not easy. Then the problem should have been done like 70 years ago. So yeah, the thing is that we have to be clear that the base that we use for maritime entitlement are different. We use law of the sea convention, and China does not use it. They use a different base. Legally speaking, it is very clear that the 9-dash line is considered illegal not by us, but by the court. So everything is clear, actually, settled legally speaking. But now the fact that China keep coming, a different story. So we don't really talk about any legal matters anymore. So I think this is a matter of how Indonesia and China would negotiate about that. To be honest with you, with the behavior that they have at the moment, I don't really see yet how we can solve this issue very soon, to be honest with you. So, but what Indonesia should maintain is its legal position that legally speaking, we are entitled to that. And if there is an overlapping, it is not with China, but with Vietnam and Malaysia. So what I propose is actually for Indonesia and Vietnam and Malaysia to really speed up this maritime boundary delimitation, and then the position will be stronger, because that position will be defended by not only Indonesia, but also by Vietnam and Malaysia, because those are two neighbors that legally speaking, with whom we should delimit our boundaries, not with China. So if we cannot really collaborate with with Vietnam and Malaysia, the position or decision can be worse, because the situation over there is not defended by these three. That's my opinion. Thank you.
Okay, thank you very much, Dr. Arsana. All right, the third question is for Dr. Wirasatria. Okay, research on upwelling is beneficial for fishermen or fishers. Have the study results have been used as input or guidance for fishermen in finding catchment? The question is from Mr. Joko.
Okay, thank you very much, Pak Joko. Yeah, this is also actually become my final goal, in studying upwelling, But I haven't reached that goal actually, because now I still have no access. What I did is just to share my research in the international journal, also conference like this, and I haven't tried to collaborate with fishermen, and then they can use some of my results. But maybe if I can access some fisheries, maybe I will do it, Pak Joko. That's, I think, in the future I will try to make a collaboration with the fishermen that can use the result of my research.
Yeah. Okay. Thank you, Dr. Wirasatria. Okay, again, I would like to apologize for the speakers due to the limited time for the question and answer session. I can only ask one per speaker. And I would like to kindly ask all the speakers to answer the questions that are presented by the participants in the Slido. So, thank you very much. Next, I would like to give the mic back to the Master of Ceremony, as it is the end of the session, first session.
Thank you, Dr. Marina, and all the speakers for this session. Ladies and gentlemen, now we will hold a photo session. To all speakers and participants, are welcome to turn your camera on and please stay still until the photo session is over.
Okay, the committee, are you ready to take the photo session? Okay, we will take a photo from various page. We will start from page 1 first. Please turn on your camera until the photo session is over. Okay, we will start on first page. 1, 2, 3. Okay, we will start on second page. Please turn on your camera. Okay, I will count 1, 2, 3. Okay, going to next page. 1, 2, 3. Okay, and the last page. Please turn on your camera. Okay, I will count 1, 2, 3. Is it enough, the committee, for the photo session?
Enough. Thank you.
Enough. Okay. Ladies and gentlemen, we would like to inform you the following matters. The next session for attendees, please break for 5 minutes, and we will continue for the next speaker for this session. Thank you.
Thank you.
Thank you.
Okay, thank you, ladies and gentlemen, for staying with us. Now we will continue for the next session and giving back to Dr. Marina as the moderator.
Dr. Marina, the time is yours.
Thank you, Master of Ceremonies, Gita and Nico. Ladies and gentlemen, distinguished speakers, we are now on the second session of this exciting conference, AGERS Conference 2021. In this session, we have 5 speakers. And the first one, I would like to read the bio, short bio. Okay, let me screen share. Okay. All right. The next speaker is Dr. Yudi Aditya Warman. He is a researcher in the Research Organization of the Assessment and Application of Technology, National Research and Innovation Agency. His presentation today is titled, okay, let me close this. Is titled Open Data Acquisition Platform for Distributed Environmental Monitoring System. Dr. Aditya Warman received his PhD in 2011 in engineering from the Hiroshima University in Japan. And his master's degree is in the US and bachelor's degree also in the US. Since 2011, he has been involved in various activities in this research organization, and the latest one, he is the chief lead engineer for the Indonesia National Ocean Data Center. Dr. Aditya Warman, I would like to invite you to give your presentation. The time is yours. Oh, it's still muted. I'm sorry, it's still muted.
Thank you very much, Ms. Chairman. First, I would like to introduce myself. My name is Yuda Aditya Warman. I would like to give presentation about open data for distributed environmental monitoring system. I will share my presentation now. Is it clear now?
No, yes, we can see it.
Okay.
But it's a bit cropped.
How about now?
Yeah, it's much better.
All right, thank you very much.
Yeah, that's good.
This is titled Open Data Acquisition Platform for Distributed Environmental Monitoring System. The idea is that for the forest fire, weather and air quality in gaining a lot of public awareness, especially in Indonesia, where we have a lot of forest fires, and the quality of air quality in Indonesia, especially in big cities like Jakarta, Medan, and Surabaya, is getting worse. So the public would like to know the quality of the Indonesian air quality. And we also, as a country, we face climate change as a serious issues that face making a lot of disasters. For example, the heavy winds and rainy seasons getting worse and worse, and flooded, many things like that. And as we know from the last 2016 of the forest fire, with the worst air quality due to the forest fire, we gain more health problems with the Indonesian with the regional people there. As a result, we need a lot of data to make the presentation to interpret the values of the problem of these systems. I'm sorry about that. So many airplanes now in my areas. One of the problem in interpreting this quality, the quality of the airs, is that we only have limited number of sensors and available data. For example, BMKG themselves in the southern Sumatra only have 4 automatic sensors, which is not really enough for calculating the quality of air quality. Hence, we need more sensors. The idea now, instead of the government making more sensors, why not make a community-based network of sensors, such that we can generate more data. This idea is taken from Automatic Packet Reporting System Protocol, or APRS. This is a legacy protocol started in 1992, still alive today. As you can see that a lot of data this is part of Tucson in America. This is commonly used for RF for communicating, transmitting the locations of the sensors, location of personnel, and monitoring mobile stations, for example. The advantage of using Automatic Packet Reporting System, or APRS, is that this is a wide area network. They can generate positions, they can distribute, they can transmit the positions, and at the same time, they can be as a repeater, means that every station can send the data to the next stations, and this information can be collected in one receiver, in one central receiver. So when this info APRS is integrated with internet connections, this can be used for citizen weather observer network, citizen weather observer program. Unfortunately, even though in these countries, for example, in US, in Europe, there are many APRS network based on the radio. But in Indonesia, as you can see, very limited sensor. For example, in Jakarta itself, there are only 3 stations currently operating, and also in other areas, for example, in Luwu, only 2, if I'm not mistaken. So in the total in Indonesia area, we only have very few, less than 10 sensors. Why is that? Because this is based on amateur radio network, which is not many people are familiar with that. So what's the idea? The idea is now the technology is already mature. We have open source hardware platforms, like, for example, Raspberry Pi, ESP32, Arduino network, and etc. Also, there is a MEMS technology. This is miniature embedded monitoring system or sensors, technology-based sensors, and OM solutions. Also, nowadays we have very low cost radio transceivers. For example, LoRa solution you can buy it for only $5, for example. This is a complete radio, can cover almost 20 kilometers. That energy harvester device. By using energy harvester device, you can operate this radio for almost like 1 year, 2 years, in some extreme cases, 10 years, for example. And also there is at the end of the system, at the back end, there's a maturity of open source database, web server, and data visualizations. We have MongoDB, we have Cassandra, we have Nginx, Apache, and so many open source software that support IoT data collections. Right? These are the open source devices and software and other systems that can be used to generate or to create open source IoT platform end to end. So the objective is that we'd like to integrate an end-to-end open source platform for environmental sensors, which consists of one, open source hardware platform, which means that we can use any hardware for our system, no matter what architecture. Number 2, we'd like to have open standard RF protocol, means that we would like to have a solution which is independent from physical layers. We don't care what kind of radio that we use. We don't care what kind of devices that we use. As long as they can transmit telemetry, then we can use this device. Third is that open source IoT connectivity means that with the open source connectivity, we can integrate different kind of devices, as long as they can connect to our system and they can display accordingly. Real-time data stream means that the data will be continuous and will be stored accordingly by using a time series database. And the last one is API support, means that this data should be able to be other people can acquire the data by using API support for further analysis. Okay. The architecture is like this. At the end, this is we have different nodes, for example, different nodes with different sensors, for example, the water sensors, the wind sensors, and the temperature sensors. But the idea is, instead of all the nodes connecting to the gateway, it is possible for the node connecting to the digipeater, and then from the digipeater to connect to the node, to the gateway. The idea is, instead of using every device is connected directly to the internet, right? We would like to have a digipeater such that the communication to the internet is through a gateway, so make the price is cheaper for the connecting, because usually to connect to the internet we have to pay a certain price. For example, the pulsa, we call it in Indonesia, right? And this gateway consists of APRS modem. This APRS modem can communicate by using communicate to node by using different kind of radio. For example, using LoRa, using 2-meter radios, 70 centimeters, or all kind of radios, as long as they can send the data to our modem by using APRS network. Then from this APRS network, we can communicate to the server by two methods. One is using APRS IS gateway or APRX, or using MQTT gateway. And then from this MQTT gateway, we'll receive it in our backend server, then visualized by using dashboard. What's the idea of telemetry data acquisition platform as an open source? One, this system has to support industry standard interface RS485 and 4 to 20 milliamperes. Why is that? Because by most of the sensors available throughout the vendors are mostly these two sensors, the Modbus and the 420 milliampere current loop interface. It is also possible for the device to support the other types of interface, for example, I2C or SPI. This is usually for experimental or for internal use, for example, the internal sensors of the temperature of communicating between internal systems. Roll-time clock is very important, such that all the data will have timestamps. And the last one, and the last one is we use APRS transceiver protocol for telemetry because one is that it's compatible with radio network or available physical layers. So by using the APRS, we can use any kind of radio, whether it's amateur radio, LoRa, or XB. And the second one, which is, I think this is very important, is that APRS support repeater, such that all the radio will become repeater, such that we can make a bigger coverage for the system. For example, usually one radio can only cover 20 kilometers, but by using digipeater, we can cover almost like 50 kilometers or even 100 kilometers. And the devices has to be open source. We are going to use two systems, Arduino for the nodes. This is to ensure that we have a big number of library and support different kind of interfaces and also low power consumption. For the embedded Linux, for the gateway, we are going to use embedded Linux because we are going to need TCP/IP, and in this case we use Raspberry Pi, or in other case we can also use BeagleBone, as long as they support embedded Linux. And the engine itself is developed using Python script and C++. Yeah. The gateway from our gateway to the server, we use MQTT or message queuing telemetry transport. Why? Because this MQTT support publish and subscribe mechanism. The advantage of using MQTT for communicating to the server is that it's designed for constrained device, low power, low bandwidth, but high latency, and the network, unreliable network. This is very important, especially for the remote areas or rural areas in which the network is spotty mostly. And the engine will be supported by using AX25 Linux kernel. The next one is that from the gateway, the data will be transmitted to the server architecture. This server architecture consists of MQTT server by using Mosquito. Then the data will be collected by using Telegraph as a plugin for the InfluxDB. And for the database itself, instead of using RDBMS as standard RDBMS database, we are going to use a time series database, InfluxDB, because this is geared toward time series, the data. And then to visualize the data, we use Grafana dashboard, such that we can make a visualization of our system. Why do we use Telegraph, InfluxDB, and Grafana? Well, these are the open source. You can use any kind of server, or you can use any kind of technology for the backend. You can use Cassandra, for example, or MongoDB, or different kind of database, Postgre, for example. But we decided to use this Telegraph, InfluxDB, and Grafana for the simplicity and the power of distributed computing. This is an example of the sensors that we deploy in Jambi. We include the sensors by using Modbus automatic weather stations, carbon monoxide, carbon dioxide, PM 2.5, soil moisture, and soil temperature sensors. The idea of this sensor is that such that we can make we can do further analysis by using this sensor by integrating weather stations, by integrating the atmospheric observations with underground observations. For example, if we have rain, for example, and then we would like to know what's the relationship between the rain and the land behind it, the peatland under the sensors, because it's possible to make the correlations between the amount of rain and the amount of water collected by the peat and the forest fire, for example. And what's the relationship with the if there's a fire or positivity to the fire? How what's the relationship between the fire, the temperature, and the quality of the air quality, for example. This is the device that we built. This is the dashboard that we make. So we integrate the value of the sensors, the collected, and the spatial data. Right. All the data will be published in our sites, and we are going to put it as well as we are going to publish it as open source. We would like to encourage people to explore our system, hardware and software, such that it will be really becomes a community sensors. What's next? It is possible for us to open our sensors for scale up deployment. We hope that by opening our hardware and our software, people can start developing their own sensors for their own use, right? And then we can create further analytics by using the data collected by the crowdsourcing. Second one, we'd like to migrate to cloud platform, because this way we don't really have to maintain our own server, but instead we can use the existing system. Second one, the third one is that we would like to integrate this by using geospatial data analytics, because nowadays all the geospatial data from the remote sensing can be acquired and can be analyzed from Google Earth Engine, for example. Right? By using the integrations with the big geodata geospatial data analytics, it's possible for us to for example, to upscale the resolutions of the geospatial data. And the last one is that we'd like to create an end-to-end environmental data platform. By creating the end-to-end environmental data platform, we are going to have it's possible for us to create supporting analytics of, for example, the forest fire, the quality of air in certain regions, or even planning for a better farming, for example. Right. Thank you very much.
Thank you very much, Dr. Aditya Warman, for this insightful presentation. So what I have on my notes that it is on the telemetry and data acquisition platform. It is a solution for Indonesia, specifically in remote areas or in the rugged terrain of Indonesia, and also in the vast ocean between the islands. And also you mentioned about the crowdsourced development of sensors and also the big data analysis of what's been gathered. Thank you very much, Dr. Aditya Warman. I would like to remind the participants to write your questions in Slido. All right, I'd like to go to the next presentation. Okay, let me share screen. All right, the next presenter. Okay, let me. Okay, the next presenter is Dr. Kunio Yoneyama. He is the director. Is the director of Dynamic Coupling of Ocean Atmosphere Land Research Program of JAMSTEC. And his presentation title is Importance of In-Situ Air-Sea Measurements in the Coastal Region, Learn from the recent International Field Program of Marine. Dr. Yoneyama received his PhD from Nagoya University, master's from Kyushu University, and bachelor's from, he is received his bachelor's degree from Kyushu University. He has appointed various ranks in JAMSTEC since 1990 until present. And currently, he is the co-chair of YMC Scientific Steering Committee and also member of the World Meteorological Organization and the Scientific Steering Committee. Dr. Yoneyama, I'd like to invite you to give your presentation, and the time is yours.
Yeah, thank you for your kind introduction. Can you hear me?
Yes, I can hear you.
That's good. I will share my slide. How about this one? Can you see
It's starting. It's starting. Not yet showing. All right, it is showing.
Okay, that's good.
I'd like to ask you to have it in the slideshow.
Yeah, I did.
Right.
And how about
it is showing.
Okay, that's good. Okay, thank you again. And selamat pagi. Nama saya Kunio Yoneyama. I'm from JAMSTEC, Japan. And first of all, I'd like to express my sincere thanks to the organizing committee for inviting me and to giving me this opportunity to share our recent knowledge today. And but after I submitted my talk title on the abstract, I noticed that a little bit, challenging, because I will emphasize the importance of in-situ measurement in this remote sensing session. But I believe that everybody understands that both does not conflict at all, because they both help each other. Okay, and today I'm talking about the importance of in-situ measurement based on the recent field campaign. We call it YMC, Years of the Maritime Continent. However, I'm afraid I'm not sure how many people know that this name or not. So my talk will start a brief explanation about this our field campaign project. Then I will mention about the our recent analysis or result. Okay. The purpose of our field campaign YMC is very simple. Simply, YMC is designed to improve our knowledge about the weather climate system of the maritime continent region and its prediction scale, and of course also its global impact. Our motivation came from the fact that even now, state-of-the-art numerical models are suffering from the systematic errors of rainfall estimation. You can see these in the right upper panel shows. Actually, this figure is somewhat old. However, even now, the tendency is almost similar. It means that you can see the numerical model overestimate over land and underestimate over the ocean. This means that our knowledge about the physics of the rainfall mechanism is still insufficient. So this fact is also affected not only in the tropical area, but also all over the world, because over this maritime continent region is very actively, convectively very active. For example, later I will show, but Madame Julian Illustration, one of the biggest cloud ensemble, very active over this region. And maybe you are very familiar with monsoon system or, of course, El Nino. That maritime continent region is a key for those areas, those phenomena. It means that if we have insufficient information, since we live in the only one Earth, it means that even for the numerical error propagate or prevail enter the globe. So it means that if we want to get accurate with the prediction in the even mid-range like Japan, we need collect information over the maritime continent region. And also, I'm not familiar. I don't know that. I'm not sure the how many people are familiar with phenomena, the so-called Madame Julian oscillation. This is found by Madame Julian about 50 years ago. You can see this left panel that huge cloud ensemble sometimes it exceeds the zonal scale is about over 5,000 kilometers or so. Such a huge cloud ensemble developed over the Indian Ocean, then propagate to the eastward along the equator, typically 5 meters per second or so. And it circumnavigates along the equator about 1 to 2 months. So it is one of the intra-seasonal oscillation. Okay, and it affects the not only the tropical weather and climate, but also the affects the, or for example, it triggers the monsoon onset of the Indian monsoon or Australian monsoon, and also it causes many tropical cyclones. And even it is believed to the key component to trigger the El Nino event. But many tropical meteorological scientists studying MJO, initiation process or eastward propagation system. And the third mystery is the modulation processes over this maritime continent region. You can see in the right panel. MJO convection developed over the Indian Ocean. However, about 30% failed to pass by the maritime continent region. It means that something happened over the maritime continent region. I mean that the interaction between the MJO and the local circulation or something. Okay, so we need to know the what's happening over maritime continent region if we even to study the MJO. I think the most Indonesian people are very familiar with the diurnal cycle of precipitation based on your experience. Yeah, it's very well known that over the maritime continent region, diurnal cycle rain is dominant. And basically the land breeze or sea breeze along the coast is a key component to produce such a diurnal cycle rain. However, since our numeric model cannot capture the exact accurate behavior of diurnal cycle rain, it means that our knowledge is insufficient, or we do not know the actual physics, how these such a land breeze, sea breeze occurred and under any other conditions. Okay, so we decided to conduct the field campaign. However, this region is of course affected by many phenomena, and so it is very difficult to conduct the only 1 month, 2 months. So YMC is consists of the 2 field campaign observations. One is the we are conducting 1 to 2 months long intensive observations, focusing on the specific topics like diurnal cycle rain or MJO or corridor size, blah blah blah. And also we need the help from the local agency over a long-term measurement. Okay, so. And so far, over 17 institutes and universities from the globe, many countries and regions joined this campaign. And this field campaign phase started July 2017. And it was originally scheduled to the end of the, it will end early 2020. However, due to some difficulty of the logistics and also recent COVID-19, some project has postponed. So far, we are planning to continue this activity until early 2023. And as I mentioned, that this field campaign consists of the many intensive observations. Next slide shows the where and when we conducted the such field campaign. I think I'm sorry, it is very difficult to see, or because only I show the abbreviation, so you don't know the meaning exactly. At least, but you can see the there are indeed there are many intensive observations happening. We are conducting the observations over this region, and but as you can see, or as you can easily guess, the some projects originally planned last year or this year, but due to the COVID-19, they decided to postpone. Some field campaign still waiting for the settlement of the current situation. Okay, so anyway, from this figure, you can see the currently there are many intensive observations we are conducting. Of course, not only from us, but as I mentioned, that many countries, many researchers from all over the world join this field campaign. Okay, so from now, I will briefly mention about some research topics that obtained from this YMC field program. First one is the myself and we at JAMSTEC conducted a field campaign of Sumatra Island in collaboration with the Indonesian agency, BPPT, BMKG, and LAPA, and also the BIA. So, yeah, anyway, and also some universities. And in addition to us, some scientists from the US and France, and also joined this campaign. Anyway, also I mentioned that YMC started from 2017, but we also conducted a pilot study 2015. So today I will show the result obtained from 2 field campaign of the Sumatra Island. Our main target was the interaction between dynacycle rain and MJO. So we decided to conduct observation in the November to December when the MJO often active over this region. And to observe this such behavior, we deployed our research vessel Mirai just off the west coast of the Sumatra, actually the Bengkulu city. About 50 or 100 kilometers off, we deployed. Actually, as I mentioned, we did 2 times. And at that time, we also get a collaboration from the Indonesian agency, BMKG and BPPT. We deployed the observation site in their with a station site. And this shows the one example for the obtained for 2015. This shows the precipitation. You can see this as a function of the time and the longitude along the equator. And this vertical line indicates when we conduct the observations. And the red line indicates the when we deploy our research vessel Mirai, about 1 month. You can see the some deep cloud convection developed in the ocean, then started to propagate to the eastward. It means that this is the evidence of the MGO convection. It means that we can observe the before MJO and also we experience the MJO convection at the later stages. So we can see the this shows the precipitation observed with the radars because not only the online BMKG radar, but also we at JAMSTEC have a Doppler weather radar on board our research vessel. So by combining 2 radars, we can monitor the behavior of the precipitation. This shows the precipitation as a function of the time and the distance from the coastline. You can see, and this indicates when the MGO convection peak arrived the coastal region. And you can see we made a composite before and after the MGO convection peak arrival. You can see before such a huge cloud ensemble arrived over this region, there are clearly, we can find very clear dynacycle rain. You can see in the afternoon convection developed over around the coast, during the nighttime, they propagate to the offshore world. Such a clear signal can be found. And after emission convection arrive over this region, such a behavior is not so clear at all. But even so, you can find you can make a line like this. Although it's not so clear compared to the before emission convection arrival, but at least we can see it's even under the condition that a huge cloud ensemble covered over the Sumatra Island, we can confirm some dynamic cycle line exists, developed and propagate to the offshore world like this one. We check the why such an interaction. Yeah, actually, we thought that during the major active phase, the cycle should be small or vanish or almost we could not observe. However, we could observe some cases. And the one key component is the surface temperature or thermodynamic contrast between ocean and land. As I mentioned, that the sea breeze, land breeze is a key component to produce the dynamic cycle rain. This shows the surface temperature time series over differences between the ocean and land. And when we this particular dashed line indicates the when the emission convection arrived. So when we made a composite for the dynamic cycle rain before or after the emission arrival, you can see the although large cloud Sumatra area covered with the large cloud ensemble, their signal or their contrast almost same. Slight behavior different. However, the temperature differences, thermodynamic differences, same. So it means that they can even they are covered by the huge cloud. They are possible or capable to produce the land breeze during the nighttime. This is because we speculate when we look at the detailed temperature profile, temperature behavior over land, over the ocean. When the emission convection cover over this region, we could see the temperature decrease. This is compared to the before the emission convection. It means that such convection causes the such a precipitation cool the atmosphere due to the evaporation cooling instead of the fine days long wave radiation cooling. So even the emission convection is very active over this region. Over the coastal region, they have a characteristic to produce the dynamic cycle rain by keeping the such a temperature contrast. That is a very important point. It means that if we want to know the dynamic cycle rain, we always should obtain the correct, accurate data set for the surface temperature, not only the land, but also the ocean. And one example, the why such an instrumentation is really important, because our data set is open to everybody, so anyone can get our data. Indeed, Meteorological Service Singapore, a researcher from the MASS, use our data. Left panel show the they calculate using their own numerical model to simulate the dynamic cycle rain and over the Bengkulu area, and using some Ariada's product as an initial condition. You can see this show the composite signal composite diagram. You can see the numerical model, the intensity and also the peak of time of dynamic cycle rain is different compared to the observation. However, they notice our data set and then they compare to our data to numerical model initial condition. They found the differences between these sea surface temperature data set between the institute data and Rihanna's product. So they decided to add 2 degrees Celsius based on our observation. Then they calculated their numerical model. You can see they correct the numerical model much improved. it means that their model itself does not change, but they only change the initial condition data set.
2 more minutes, please.
Okay. So it means that very such a initial data is important. And for example, right now there are many C-surface temperature data set is available. However, if we compare to several data set, you can see it's completely different. And my colleague checked such a differences comparing to our initial data set. As I mentioned, that we deployed a research method Mirai of the Benkuru even to 2017. When we compare the data with other such a real product, you can see sometimes some model differed about 1 or 2 degrees Celsius. So it means that the initial measurement are really necessary to evaluate the real product. See, and so of course that's why I'd like to emphasize the importance of instrument measurement, but actually it's very difficult to obtain such a data continuously. Right now we are conducting an intensive observation. We provide many tools, but usually it's very difficult. Instead, I would like to propose a new tool. And during another field campaign, the YMC, we deployed our another autonomous surface vehicle. We adopted wave glider. Wave glider means that they use a wave to use for the energy for the propulsion. Okay, and we also added, in addition to the standard meteorological sensor, we added a GNS receiver to produce to calculate the water vapor. Okay. When we deploy our such a wave glider around our research vessel Mirai, we can compare, since as I mentioned that we have a Doppler with a radar on board, so we can compare our radar data and surface data obtained by wave glider. This shows the time series of surface meteorology obtained by wave glider. You can see if the someday rain occurred and the drastic decrease of sea surface salinity and sea surface temperature occurred. And at that time, when we compare to the data obtained by our weather radar, we can surely confirm with, at that time, certainly precision occur over this region. And we also notice some drastic change of the wind. When we compare our Doppler radar's wind data, we can also confirm this one. So it means that this data obtained by wave glider should be correct one, and also it provides some evaluation data set for our Doppler radar, vice versa. Okay, so the collaboration is a very important issue. And in addition, as I mentioned, that we deployed not only the surface meteorology but also GNS receiver. And this shows the result using a GNS signal. I'm not sure, but hopefully many people right now know that about some knowledge. Using a GNS signal, we can calculate the integrated water vapor from surface to the troposphere. So when we calculate such water vapor obtained from wave glider and compared to the radio sound conducted at Palau Island, and also we compare to the satellite-based water vapor. You can see most of they corresponded well. And big advantages using a wave glider is the radio sound is usually we launch 4 times a day, and also for satellite 1 times a day or the same location also. But since we can obtain the water vapor data continuously about every 10 minutes, so we can sometimes we can see the drastic change associated with the heavy rainfall or cumulus or cumulonimbus like that. I will, due to the time limitation, I will skip. But this sample shows how the wave glider measurement affect or convenient to detect some convection signal. Okay. Okay. I will close my talk, but before closing my talk, I will also point out one point. Today, I introduced the recent activity from the YMC, but this is based on the intensive observation. But also, we are conducting the long-term we have a long-term collaboration with many international agencies, BPPT and BMKG and so on. And this shows some example from the collaborative work between JAMSTEC and BPPT using international research base of Bernard Jair. We deploy the monitoring system. This system is measure the surface measurement, of course, for a long time period. So we believe that such collaboration is also important, as well as such long-term measurement is a key. So by combining the such long-term measurement and our intensive observation can help us to understand the why such a heavy rainfall occur over this region, and also the source of the precipitation. Okay, that's it. So I do not lead this on, but today I try to talk about this point. That's it. Thank you so much.
Thank you so much for this wonderful presentation, Dr. Yoneyama. All right, it's a very interesting study on the various effects over Indonesia, and you mentioned about the study of trying to understand the multi-scale variability for the maritime continent and weather climate system, and also its global impact. Thank you very much, Dr. Yoneyama. Okay, I'd like to remind the participants to pose your questions in Slido so that we can read them during the question and answer at the end of the sessions. All right, I would like to go to the next presenter. Okay, let me share screen. All right, the next presenter is Dr. Dian Nuraini Melati. She is from the research organization of BRIN, and her title of presentation is Utilizing Earth Observation Data for Land Monitoring. She is an engineer in BRIN, and she received her PhD degree in 2007 from the Department of Forest Inventory and Remote Sensing, University of Göttingen. Her master's degree is in Spain, Portugal, and Germany, and bachelor's degree from Gadjah Mada University. To Dr. Melati, I'd like to invite you to give your presentation, and the time is yours.
Yeah, thank you, Mbak Marina, for the nice introduction. So first of all, I would like to say many thanks to the organizer already invited me to share my work in this such a exciting international workshop. So just let me share my slide. Can you see the slide already?
Yes, yes, I can see. It needs to be on slideshow. Yes, now it is on slideshow. It's great to go.
Yeah, thank you. So today I will be presenting on the topic of utilizing Earth observation data for land monitoring. And just for your information, that this study covered in this talk particularly is a part of my PhD study. So let me talk a bit about the motivation of this study. Earth observation, as we know, collects information of Earth's planet, either physical, chemical, or biological data through remote sensing technologies. And EO data play a key role for monitoring, understanding, and predicting the current status, future, and changes of the human Earth system. Data collection from remote sensing and in situ measurements are important sources for recent knowledge related to physical and anthropogenic processes. And finally, the use of remote sensing data plays a major role on land monitoring due to spatially explicit measurements of the ground surface of a large area, as well as the ability to measure repetitively. So in this talk, there are 3 case study examples. Our first study is on the land use land cover change over the tropical rainforest landscape under transformation. And the second study is on the land use land cover mapping using high spatial resolution image. And the last study is on the above ground biomass mapping. Come to the next slide. So as all we know, that a great number of green plants in the tropical rainforest play an important role in the context of the global carbon cycle. Indeed, FAO reported that forest carbon stock globally declined in the last 25 years due to deforestation and forest degradation. And it was reported that deforestation was mainly due to the tropical forest conversion into agricultural land. Nonetheless, as we can see here in this figure, that the rate of forest loss has decreased considerably in the period of 1990 until 2020. For example, here in these figures, it shows the annual rate of forest expansion and deforestation. And in the last 5 years, in the period of 2015 until 2020, the rate of deforestation was around 10 million hectares per year. And it was actually decreased from the period before, from 2010 until 2015, it was around 12 million hectares per year. And in Indonesia itself, the forest extend in the last 5 years, between 2015 and 2020, the decreasing was actually quite little, and we can see almost a stable of forest extent in this period. And why then land monitoring is necessary? In this regard, knowledge on the existing and the transformation of land use system processes is fundamental to compromise the trade-off between economic benefit and ecosystem services over the landscape. Monitoring land use system itself play a key role, first to provide information for historical land use change and information about the cost of any change over time. And the second, to serve baseline information for better planning on sustainable landscape management. Finally, it will provide scientific knowledge to provide information for decision-making and evaluate the respective past policies. And starting for this slide, actually, I will start talking about the case study. This first study is looking at the land use land cover change within a study area in around Jambi province. And it is actually a collaborative research. It was a collaborative research between Göttingen University, Bogor Agricultural University, Jambi University, and Tadulako University. And it was funded by the German Research Foundation in the framework of a collaborative between German and Indonesia research. And the study here that I will show about the historical land use change is actually part of study which was looking at the trade-off between economic and ecological function underlying current land use dynamics that was published by Clough et al. In 2016. Let me show you the our study here. It's in Jambi province, and let me talk a bit about this. What it's shown here, that these are a lot of distributed plot sample in color and the orange color, and they are actually a household survey. They take economic or social economic data, and in these blue plots here, the data about biodiversity, ecological functions were taken, and the land use land cover change study itself, it is in these 2 areas around Bukit 12 National Park and around Harapan landscape. And yeah, here we can see the land use land cover in 1990. And actually this land use land cover map were produced from a time series of Landsat satellite images within the study area with a visual interpretation. And actually it was intensive work together with the remote sensing and GIS laboratory of forestry faculty at the Bogor Agricultural University. And here we may see the change between 1990 into 2011. And in this chart here, we see that the forest was lost during 1990 until 2011, and the other side, the tree crops were increasing. They are oil palm plantation and rubber plantation. And from the table here, there was a forest loss from 1990 until 2011, around 30%, and it was converted into oil palm around nearly 11%, and then to other tree crops such as rubber around nearly 6%, and other like shrub or bush around nearly 13%. Yeah, and the second study is land use land cover mapping using high spatial resolution. In the study, I utilize rapid eye images. It has a 5-meter pixel size, and it has 5 bands. They are blue, green, red edge, and near infrared. And in this mapping, an object-based classification was carried out to allow the evaluation of high spatial resolution image for land use classification. An object-based image analysis itself consists of first image segmentation, and I applied mean-shift segmentation algorithm. And for the image classification, the classes were secondary forest, rubber land, oil palm plantation, shrub or bush, bare land, and settlement. Here, the classification was done using machine learning, which is for random forest classifier using 8 predictor variables. There are, as you can see here, 5 spectral bands of rapid eye, 2 vegetation indices, and also the ratio between the perimeter and area of each segment. Yeah, let me talk a bit about the image segmentation. So as all we know probably that the selection of optimal segmentation parameter is quite challenged. And until now, there are no standard approaches to quantitatively evaluate segmentation accuracy. And in this study, best segmentation parameter setting was selected by comparing between the reference object and the segmented image with different parameter settings. The reference objects were around 30 objects that was visually digitized. And how to evaluate the segmentation? Hoover matrix was selected, in which this matrix evaluate the over segmentation, under segmentation, correct detection, and misdetection. And by using the mean-shift algorithm that was used in this study, we might define 3 different parameters. They are spatial radius, range radius, and minimum region size. And here are the parameter settings that I selected, and then it was combined one to another. And from the combination, we produce around 36 different combinations. And actually, this scatter plot was the way to see the score produced from the different combination. And in this case, in my study, and the best parameter setting was chosen on the setting which has a high over segmentation but still performing the correct detection. Actually, was from the study, there was the hikes. There were higher over segmentation rather than what I have chosen, but it doesn't maintain the correct detection. And for image classification, and for the training data, I established a 2.5 kilometer square grid from systematic sample, and visual interpretation was done for each segment within a square 200 by 200 meter at each grid point. And for the map validation, I also collected independent data in the field. It was selected with the stratified random sampling within a buffer of 500 meters from the road, and land use was observed in the field for each segment with a square plot 100 by 100 meter at each validation point. And just for information that actually the overall accuracy of the map using a model prediction produced by a random forest classifier. So this classifier used 1/3 of model of training data. It gave me a good overall accuracy at around 80%. But then when I use independent data for validating, the overall accuracy was lesser at around 68%. And there are still a lot of things can be researched in this matter, because, for example, in the case of confusion between oil palm and shrubs that I found, actually in this map, it doesn't defining different age of oil palm, and actually it has produced a lot of confusion. And the other thing is about the confusion between rubber and shrubs. So the data or the rapid eye image was taken in June, and in this time the rubber was defoliated, but then give a lot of spectral response of shrubs. But in fact, in the field, it is rubber rather than shrubs. Yeah, and the last study was about above ground biomass mapping. Here, the field inventory implementing a stratified sampling for data collection, and it was generated from NDVI strata. Here, you can see from the 3rd class until 5th class. Why? Because I did the visual inspection in this area, and this area cover forest area. And sample plots were located purposefully within 1 kilometer distance from the road, and also along the existing transect of rectangular plot from the previous systematic inventory. And yeah, the plot design itself is a cluster of 2 nested subplots, each with 3 different sizes of rectangular and square subplots. And yeah, here we can see the distribution between diameter and above ground biomass around the study area from the inventory data. And we might see here that much height of stand density here shown in trees per hectare was with a diameter around less than 20 meters. And the above ground biomass, the high value was found with the diameter less than 50 centimeters. And the way to regionalize above ground biomass over the areas, here are the model prediction and validation that have been done. First, relating its targeted dependent variables with its subset of predictor variables using a multiple linear regression, and two, selection a subset of predictor variables through a stepwise exhaustive search approach. And the dependent variable itself was a background biomass by using allometric by Brown, and the predictor variables were 5 bands of rapid eye, 6 different vegetation indices, and texture indices with 3 different moving windows. And the model validation was using leaf-one or cross validation. And here it is, the map with the moderate value of R square, adjusted R square, and root mean square error. And this to give an idea for a selected area. And actually, this give a further study. It's an opportunity to develop, for example, in the model prediction, because here I found that there were unplausible value with an extreme value. So perhaps in the future, another model prediction could be applied. And yeah, that's all my presentation today. Thank you.
Thank you very much, Dr. Melati. Very interesting presentation about land use, land cover change in the Jambi area. Thank you very much. We will have the question and answer at the end of this session. So please, I would like to remind the participants to post your questions in the Slido with the link already posted in the chat. Yeah. All right, I would like to go to the next presenter. Let me share the short bio. All right, the next presenter is Mr. Yudi Anantasena from the Research Organization for the Assessment and Application of Technology, National Research and Innovation Agency. The title this morning is Marine Survey Technology, Indonesia Research Vessel Fleet. Okay. Mr. Yudi Anantasena obtained his master's in geology from Tokyo University and bachelor's in geology from Bandung Institute of Technology. Mr. Anantasena have been appointed various positions in BPPT, and the latest one is as Deputy for Natural Resources Development Technology of BPPT. I would like to invite Mr. Yudi Anantasena to present his presentation. The time is yours.
Thank you very much, Mbak Marina. Can you hear me? Is this okay, my voice?
Yes, I can hear your voice.
Okay, thank you very much. Assalamualaikum, selamat siang, good afternoon, distinguished speakers and participants. Sorry. Okay. Participant to the 2021 IEEE Asia Pacific Conference on Geoscience, Electronics, and Remote Sensing Technology, or AGERS. Nice to meet you all. I hope you still in the good health. Yesterday we heard various presentation and application of remote sensing technology and geoscience technology that are applied to land and coastal areas. On this second day of the exciting conference, I would like to present regarding ocean observation technology, especially about marine survey technology, specifically the Indonesian research vessel fleet. Sorry, can the committee share my presentation, or I have to share by myself?
Okay, the committee. Oh yes, it's coming. Yes.
Okay. Well, we are waiting for the presentation. Huh? Okay. Hello.
Yeah, maybe we can wait a few more seconds.
Okay.
it's
Okay.
maybe it's the Wi-Fi problem.
Okay.
The committee, please help.
Maybe I can share by myself, Mbak Marina.
Sure. Yes.
Okay, I will try.
All right.
Okay, we can see.
Great.
Okay. The problem in committee Wi-Fi. Okay, okay. Let's go to the third slide. Next slide, please. Oh, it's okay. It's okay. Okay. At least we Indonesia, I mean, have 12 marine research vessel, which is operated by several institutions, such as BPPT, now is merged to National Research and Innovation Agency, has been operated for research vessel. LIPI also now with BPPT merged also to BRID, National Research and Innovation Agency, operated to research vessel. 6 research vessel we call Barunajaya, which is using the number Barunajaya 1, Barunajaya 2, 3, and 4, who operated by BPPT previous, and Barunajaya 7 and 8 operated by LIPI, and the others, Pusidros or the Indonesian Navy, operated 2 research vessels. That call Rigel, KRI Rigel and KRI Spika, and then they I mean Pusidros will also get or have the new research vessel in the near future, I heard, and it will strengthen our marine research vessel fleet in Indonesia. And then the others also marine KKP or minister, marine fish and fishery minister, also operate 3 research vessels. Marine resources ministry operated 1 research vessel, which is operated by different division. The task of this fleet is to conduct ocean floor mapping, support installation of underwater utilities, support of exclusive economic zone extension program, and support the country research program and appointed national program. This morning, I would like to focus on presenting the research vessel operated. It was operated by BPPT. Now we will operate it. They will operate it by BRIN. They are we call the Barunajaya 1 until 4. Barunajaya fleet was formed with acquisition of the first 3 research vessels, which is Barunajaya 1, 2, and 3, started built in France in 1986, but I mean Barunajaya 1, 2, and 3 is arrived in Indonesia in 1990. The task is to be self-sufficient in conducting inventory of potential marine resources in Indonesia. The Barunajaya 1 function is multi-purpose deep sea research and is able to map the seafloor down to 11 kilometer depth. It means that Barunajaya 1 have a multi-beam echo sonder for deep sea it can maximum reach until 11 kilometers. It is also function for researches in meteorological ocean observation, hydrooceanography, environmental baseline assessment, sediment and biota sampling. Barunajaya 2 task is on geophysical and is capable to conduct 2D high-resolution seismic and related researches such as ocean geodynamic, digital and geohazard survey, and also site survey. And then on the upper right, Barunajaya 3 function is for oceanography and geology. It is capable to map the sea floor down to 5 kilometer depth, and it means Barunajaya 3 have multi-beam for middle depth sea until 5 kilometer depth, and conduct research on meteorology, ocean observation, hydrooceanography, environmental baseline assessment, and sediment and biota sampling as well. And the last for Barunajaya 4 function is oceanographic and fishery. It is equipped with troll and acoustic equipment, able to conduct research on hydrooceanography, conduct bathymetric survey down to 5 kilometers, environmental baseline assessment, and buoy recovery and development. Buoy recovery and development also can conduct it by Barunajaya 1 or Barunajaya 3. Next slide, please. Since the arriving of Barunajaya 1 to 4, I mean Barunajaya 1, 3, 2, 3, and 4, the management or the division has gone through several name changes, and the latest is called the Marine Survey Technology Unit. And since 1989, they have excelled in providing service to support marine observation, mapping of various applications. They become the vital team in the search and rescue campaign during marine accident and hazard. Furthermore, they become the main partner in conducting economic exclusive zone extension and underwater fiber optic survey. And all these activities are based on presidential decrees, such as for deployment and buoy recovery survey, or and support marine data, also for accelerate submission of EEZ extension according to United Nations law of the sea. Next slide, please. Regarding human resources, the Barunajaya fleet is supported by 152 very capable personnel. They operate, maintain, and conduct each and every scientific survey and humanitarian campaigns. The figure on the right side shows the statistic of educational background and with the program of BRIN to improve the human capacity and competency, Barunajaya fleet will be more prominent, and I hope the team will be more can maintain the good performance, and also will be more prominent. Next slide. I will tell you some of the regarding of our involvement in the national program. Next, please. Such as Barunajaya also supports the national program, what we call number 2, because we have several national program which is already determined by Indonesian government for program number 2, namely on infrastructure and regional equality. It has been actively supporting the marine survey of tsunami early warning system since 2020 until at least 2024 in deployment and recovery of buoy or installation of CET, because in support for tsunami early warning system, which is coordinating by BNKG, we or BBD have responsibility to build and maintain the sensor for tsunami warning in ocean area. Next. For the national program of food, water, energy, and environment sustainability, Barunajaya also have conducted survey for underwater fiber optic network, which aim to connect the islands of Indonesia by increasing information and communication network through installation of fiber optic for at least 57 cities. This program is called Palaparing. Then at least in 5 years ago, since 5 years ago, since 2017, 2018, 2018, 2019, 2020, and also this year, we already involved to do survey for a Palaparing project, which several private company or state company in several areas, but especially in western part of Indonesia. Then you can see on my slide. Next slide, please. Through the national program number 5, the defense and security, Barunajaya fleet have actively involved in bathymetry mapping to support the program of Indonesian National Continent Extension. This program actually have done since 10 years ago, maybe more, of 12 or 15 years ago, because in 2010, Indonesia have increased or extend the area in the west of Aceh, approximately about 4,020 kilometers square as EEZ extension. Then now, since 5 years ago, we also do in north of Papua. Then we propose the extension of this area almost to 200,000 kilometers square for Indonesian proposal to extend our EEZ in north of Papua. But in this area, we also have to coordinate with the other countries such as Papua New Guinea or Palau, and the another area also we will do the extension for more extensive area in the West Sumatra. As I thought that we in 2010 we already have 4,200 kilometers square. Then we will propose to United Nations that in West Sumatra we have possibility also to increase the area or extend the EEZ area until more than 200,000 kilometers. Furthermore, between 20 years of 2020 and year 2024. There will be also a bathymetric and seismic survey on West Sumatra and south of Java area. Next slide, please. Regarding humanitarian missions, Barunajaya Fleet have supported various search and rescue campaigns. For example, we in 2000 Makassar Strait, after the earthquake, tsunami, liquefaction disaster in Central Sulawesi, Barunajaya 1 was sent to bring humanitarian support and to map the seafloor. So we can see on the slide, then since 2020, we also involved to search Bahu Ganjaya ship that collided with a tanker in Harimau Island and sink in Sunda Strait. And also we involved for search and rescue or black box searching for the last 2 years ago for Lion Air in 2018, then also the last one in 2021 for the Sriwijaya ST-182. Next slide, please. In the closing, the Barunajaya research vessel is ready to spot the national program, assist in the natural resource inventory and observation activity, as well as contribute in a humanitarian mission. Then we will do it in new agency, what we call National Research and Innovation Agency. Then with the new agency, bigger agency, and have a good, maybe more better management, we hope our Barunajaya fleet still exists and can do more prominent. Thank you very much, Bu Marina.
Thank you, Mr. Anantasena, for the very nice presentation, showing the long track records and achievements of the Barunajaya fleet. Okay, I would like again to remind the participants, if you have any questions, please write up in the Slido, so we can have the question and answer session at the end of this presentation sessions. Right. Again, thank you very much, Mr. Yudi Anantasena. Next, we will go to the next presenter. Let me share my screen. All right. All right. The next presenter is Mr. Michael Wisnuwardana Siagian. He is the managing director of PT Terra Drone in Indonesia. He will present a title, "The Role and Outlook of Drone Technology in Remote Sensing Application." Mr. Siagian have received 2 master's degrees from Bandung Institute.
The first one is bachelor.
Oh, okay, sorry. The first one is bachelor. All right. So in 2013, Mr. Siagian received the master's degree from Bandung Institute of Technology, and the bachelor's degree also from Bandung Institute of Technology. He has various appointments and currently is the managing director in Terra Drone Indonesia. He has experience in various appointments as speakers at various meetings and conferences. And he is also have experience as aerial mapping survey as project manager of the PT Wijaya Karya in 2016. All right, I would like to invite Mr. Siagian to give his presentation. The time is yours.
Okay, thank you, Bu Marina. Okay, let me share screen ya, Bu.
Yes, Pak.
Oh, is it okay?
Yes, it's good. It's clear. Yeah.
Okay, I would like to revise a bit about the title, so it's become more clearer. So, hi everyone. It's been an honor to be here with all you guys, with researchers, developers, and tech enthusiasts. Many interesting things I witnessed since yesterday through this event, and to be honest, it's quite overwhelming for me to digest all at once. But it's very interesting. And in this very moment, I'd like to share something a little bit more lightweight and a little bit down to earth, literally. It's about drone. I would like to present about Indonesia drone industry outlook and drone technology for remote sensing applications. So, yeah, I will explain about Terra Drone, what I represent, and drone industry outlook, and what are the applications of drones today based on our use cases. Okay, allow me to introduce Terra Drone. My name is Michael from Terra Drone Indonesia, part of Terra Drone Corporation, who provides drone-related works or solving drone-related problems to the industries. And based on the last publication, Drone Industry Insights recognized us as the biggest, which we exist in 25 countries from 3 different backgrounds, which are service providers, hardware developers, and software developers. We will try to put a big effort to use high-end technology to deliver values or benefits to the industry. And in Indonesia itself, we keep strengthening our system by opening up to the research and development of technology, any opportunities and contribution to the nation in order to achieve sustainable growth. So we are putting ourselves involved in all the opportunity for research and development, what I heard earlier about the gas sensors, and also like NDVI, oil palm mapping. It's very interesting. And yeah, Terra Drone is basically open up for any collaboration in the future for research and development. So this is our fleet, and we have done various work to the industries across the nation. And we use many payload sensor, because drone is just a platform to bring sensors. And what we're talking about is aerial drone. So the vessel that I watched earlier, it's also drone, can be considered a drone, but in Terra Drone, we are still focusing on an aerial platform. Yeah. So based on researches published by the media, drone technologies is considered as the next big thing for the 4.0 era. From personal and hobby use to military grade, drone is become like a daily technology. There's going to be forecasted, there's going to be like a easier and cheaper drone solution, So it becomes like just like operated like DVD players or smartphone. But the market opportunities for drone across the globe can reach 100 billion US dollars, and drone market growth until 2024 could reach up to 24.5%. And until now, we also got information that number of consumer drones registered by FAA in the USA is 770,000. There's so many operators, so many users of drone. And among that, Asia has the biggest growth. Yeah, you can see the chart. This is from Drone Industry Insights, which due to the demand of the developing countries, Asia, the projection will be double. The drone market size will be doubled in 2025. So yeah, this is a big opportunity and also big concern for all the stakeholders to put the maximized effort to grow drone implementation. Yeah. Go to the narrower scope to Indonesia, we have seen like the spraying drone is being used. Cargo drones will take off. It's not like a last mile delivery, not just last mile delivery, but cargo drones from port to port. It's now being initiated, and government, regulatory bodies are keep improving and making a better regulation, a more suitable regulation. Another application, we can see that in disaster response, we already use drone, which is to, I can explain later in applications. And also in construction sector, it becomes a standard tool. And also oil and gas companies has utilized drones also in Indonesia. Mining and quarries also use drone with various sensor. We explain also based on our experience. And yeah, utilities, power, especially power lines, they have used drones also in their operation. So what are the applications? This is the main topic. Based on our use cases, drone application in industries, by looking at the energy sector, energy industries, oil and gas, infrastructure and construction, disaster response, mining, plantation and forestry, power and telecommunication, drone has been widely utilized in Indonesia, and we have various cases to show you that we have been involved with all the entities to provide our service using drone. Based on the payload, based on the available payload today, that we can classify drones like this chart, this figure, like in remote sensing to the left, photo and video as the payload. Photo, you can break it down to like multispectral camera, RGB camera, natural color, and thermal camera, and for video with image processing, and LiDAR, laser one, GPR, ground penetrating radar, magnetometer, and that's the non-contact. And for the contact, the one that has to make contact with the object is ultrasonic testing and gas detector. Maybe different kind of gas detector than the earlier explained. And for the manipulation part, the red one is for agriculture, sprayer, radio relay for communication, painting and blasting in oil and gas, cargo and materials for logistics, and projectile launcher. Not the military one. We're not discussing about the military and public safety right now, but maybe like a seed shooting, seed for the agriculture. Yeah, we can use drone right now for that. And what drone can do in energy and oil and gas. So basically, in short, it's for inspection, monitoring, and mapping. So the application, the title could be like in confined space, yeah. And then because it's pretty dangerous, is regarding the safety, tank, vertical structure like flare stack, horizontal structure like pipe rack, yeah, and under deck, and also pipeline. And one of the benefits right now is to reduce illegal oil tapping. We are using drones to monitor about criminal activities for oil tapping. Yeah, and that's really good, really beneficial. So this is our example on the oil and gas sector. For example, this is flare stack. That's the flare tip, and the insulation part. You can see the insulation part is on the left one. It's being torn off, and yeah, I add some picture there for the thermal ones to monitor the pipeline. We can use drones right now to sense that, yeah, and fire hotspot within the area. Another example is for oil spill detection. It's very important for the environmental impact. Yeah, we can detect like a distinct oil spill spot, and this is very useful and time saving. And for the infrastructure and construction, most of it is topographic mapping and land use mapping, also 3D modeling. And yeah, we can see the graph, the illustration here. While using photogrammetry techniques combined with LiDAR techniques, it will produce like a colored point cloud. And from that color point cloud, it will be filtered into digital terrain model. Yeah, some may use the digital surface model, but most of it use digital terrain model or the contour map. Yeah, this is the basic output for the construction. For example, like urban area, we can also assess the infrastructure, the density of the residential area, everything. And I want to show you guys about our video for the LiDAR. This one. Yeah, this is the example of a LiDAR survey output. Yeah, so it's basically point cloud, and yeah, it will be filtered down to the digital terrain model, and yeah, it's very useful for the construction right now, especially for a hilly area which has a lot of trees, without sending people to cross over all the area. Yeah, of course, there's going to involve a little bit of a ground survey also to check the accuracy of the survey result. Yeah, and this is another example for river basin, river flow. We did that for the power generation potential of the river. Yeah, this is the comparison between the orthophoto, the left one, and the right one, the contour map based on the terrain model. Okay, next one is for mining industry. So there's been a lot right now. Volumetric survey, geophysical survey, not just a topographical or orthophoto imagery, but also right now available is geophysical survey. The use are for mining site monitoring, analysis of stockpile, aeromagnetic or for magnetic anomaly, magnetic profile, and for design, pre-construction. That's it. This is the example of the most basic one, the orthophoto, and also the same like the what I show you in the construction. That's the topographic model, DSM surface. And this is the next one. We've done research also with the university about the ground penetrating radar using drone. And in mining area, we also did some research project in a peatland and also urban area to compare the result. And even though the result is quite acceptable from the industrial scale, but I believe this could come up with further study to implement, to standardize that this ground penetrating radar can be used within the country, for the industrial practitioners. This is the sample result on the left. I believe this is still considered as remote sensing. And the next one is the drone with a magnetometer, aeromagnetic survey. This is the profile of the result. And we have done this research also with our partner. And the result was acceptable, yet it requires further comprehensive research. I hope I can inspire you for some more research using drones. And then disaster response, like what happened in our country, Indonesia, disaster response. Drone can be useful for risk assessment, damage assessment, and also monitoring, recovery, rehabilitation, and everything. And provide
2 more minutes, please.
Okay, Boo. You can see from this video, this is 3D model of Mount Merapi in Magelang. This was for research for a lava flow forecast and hazard prediction. And this is 3D model of on the peak of Mount Gunung Agung. This is taken by photos of drone using photogrammetry techniques. Yes, volcanology is one of them too. And this is forest fire in West Java, in Mount Papandayan, to have a good result on a good estimation how to control or to contain the damage. Okay, next one, plantation forestry, the most useful one. This is to assess the concession area regarding the crop. We have done like for paddy field, oil palm, rubber, and also mangrove. And we use another sensor, multispectral, for health monitoring. We use also combined with the natural color to have the best result. This is also requires further research. Last one, power line and telecommunication company. This is for inspection and vegetation management. I can show you guys like this is vegetation management using 3D model So we compare the conductor model, the cable, with the topographic. Yeah. So we can identify the potential threat to the conductor. This is using LiDAR and photogrammetry. This is another one for telecommunication tower. We flew drones to assess the structural integrity and assets condition. We often 3D model the tower too. Yeah. Okay, that's it. So to wrap it up, there's 3 things I want to say before my time's up. That drone technology plays only a small role in industrial sectors and environmental activities, but hopefully that small role has big impact for improvements and efficiency. So yeah, the industries, the researchers, tech developers, tech enthusiasts, and everyone has also plays role in the improvements and efficiencies. Yeah, and drone just plays only smart role, but I hope that's going to be a big impact. And while growing fast, drone technology has started to lose its wow factor, but instead requires more serious attention under the synergy of all the stakeholders, regulators, users, communities, developers, service provider, in order to maximize the benefits. Otherwise, the market potential, what I explained earlier, is stage potential, and yeah, with lack of synergy, of course, it's going to be pretty chaotic between the development of the technology and also the utilization is not in synchronized, yeah, and it's not regulated. So the key word is synergy and serious attention. We, Terradrone Indonesia, encourage research and educational institution to do further studies in every drone application to maximize its potential benefits. And we are open for that. And associations and government agencies to set the standards of the output and to promote the result. There's a lot of association related to drone right now, and mostly for the application also. For mapping, associations, yeah, we encourage that, and regulators and end users to embrace every drone technology's implementation along with the development process in Southeast Asia, like other countries have set this area just for drone development. So yeah, that's I hope that can inspire that in Indonesia is going to happen soon to maximize the potential development of drones. And the last one, developers and service providers to give the best experience and yeah, then become serious, pay serious attention for the industries to fit on purpose, to provide fit on purpose solutions. Thank you. That's it from me, Bu Marina.
Right. Thank you very much, Mr. Siagian. Very interesting presentation about various applications of the drone technology. And it is a promising technology, especially to map these remote areas or difficult to access areas. Yeah. So, for example, one of the slides is showing the terrain model. As a geologist, one can see the changes of the sinuosity of the river, which is really nice. All right. Thank you again. That was the end of the speaking session. And now we come into the question and answer. I would like to ask the committee to show or inform us about the questions that the speakers have posted. right. So, okay. Maybe we can start from the first question. So this question is for Dr. Dian. Which part of your study is the most difficult to analyze, and how do you validate the results? In here, I do not have who asked the questions, but you might answer them.
Yeah. Okay. I would say that for me, they are all difficult and have different way on research performance. So, for example, for the first study, visual interpretation was done as it employed series of lenses, and we aware that there are challenges by using this optical image with the cloud coverage, and a thorough selection was done actually by selecting the data sets in this quite large area to select this area with cloud cover in the image. So for this case, visual interpretation with expert and local knowledge, which contribute in this collaborative research, was very helpful. And validation was based field survey by establishing stratified sampling according to the classes. And for the second study, start with the automatic processing, applying object-based classification. This study use validation from the field and found that more work should be done, such as defining different ages of oil palm and other. For example, for rubber mapping, we could try different acquisition images for classification with similar to the time of fit work that will be done for validation. And for above ground biomass mapping itself, validation in this study was still using training data with a common validation way, which is leave one out cross validation. But for further study, I suggest to use measurement from the field to validate the model, which was not able to be done in this study. Yeah, I think it answered the question, Mbak Marina.
Yeah, thank you very much, Dr. Radian. Thank you for the comprehensive question. Next, we want to go to the next one. This question is for Bapak Yudi Anantasena. The question is, for the delivery of national survey ship fleet, do you think PT PAL can be involved?
Thank you. Thank you, Pak Arifin, for the question. The question from Pak Arifin.
Sorry. We have a long story and collaboration with PT PAL Indonesia since the first time our Barunajaya research vessel arrived in Indonesia in 1990. PT PAL involved in our maintenance program. It is mean our repairing or also docking or our ship in the beginning in 1990 decade. We did in PT PAL. But up to that, we also have done in another state company or private company. But recently, in last year, in 2020, PT PAL Indonesia involved in the Indonesian Tsunami Early Warning program. Some of our Indonesian buoys were built by PT PAL Indonesia. If I am not mistaken, there were 11 buoys built by PT PAL. The activity or including manufacturing, also testing, dry test and wet test, including in PT PAL last year. I think that's Bu Marina.
All right. Thank you very much, Pak Yudi Anantasena. Next question is for Dr. Adit. but I'm not sure if he is online right now, as he is on the way to the.
Yes, I'm online.
Oh, okay, you are. All right. So let me ask the question then. Arduino is the old school hardware that we all know the quality. You are able to provide future improvement of APRS?
Okay, thank you very much. Now, first of all, we have to define what's the meaning of old school, right? If you are saying old school means that this is old technology exists for a few years, if you can see that APRS itself is very, very old.
I'm sorry, we cannot hear you.
No. Hello?
All right, we can hear it. Yes, we can hear you now.
Okay, now if we are looking, what's the meaning of old school? If the meaning of old school means the technology exists for a certain time, right? You can see that APRS itself is a very, very old school because it exists from 1990, right? But APRS has some advantages. For example, one is that APRS capable of multi-hop, means that you can transmit from one radio to another radio. LoRa doesn't have this capability. Everything has to go through gateway. That's why we merge old technology, APRS, and new technology, MQTT, right? I mean, means that we get the benefit of both worlds, right? You get multi hops repeating, and you have delivery guarantee of MQTT. That's the protocol number one. So we have to define not every old technology or not really old, right? The technology that exists for a certain time doesn't mean that we have to scrap it. That's number one. Second one, when you say low quality, you have to define what's the meaning of the low quality, right? If you are saying that low quality it means that you cannot guarantee the what you call it, the reliability, well, not necessarily. Arduino, I mean, it's already proven, it's used by many people. Now we have to make sure that we are picking the right technology for the right things, right? For example, in this case, we are using two kinds of microcontroller. One, we are using Arduino, not necessarily Arduino, but we are using Arduino technology because we built our own microcontroller based on AVR, right? But we use AVR, this AVR microprocessor, but we use Arduino library. This is a different concept, right? Arduino is a framework. You have a certain library, right? The core of it is AVR. So we use AVR with Arduino library, two different things, right? Now, if you are saying that low quality, you have to define what low quality. If it's reliability we are talking about, Arduino is reliable. But if you are saying that Arduino is 8-bit, well, again, we are looking at the framework. So because most of the devices that we use is more than 8-bit, for example, 12-bit or 30 bits. So we increase our APRS instead of using 8-bit to 13 bits, including the error checking, etc. So if you say that low quality is not really low quality, because we increase the data bit, right? For the future improvement of APRS, then again, APRS is only one of the frame, right? So, for example, if we are looking for the what kind of improvement that we are looking for, the APRS. One, we are looking for the security, for example, because APRS is open framework, means everybody can read the data, right? If they have the device, they can read the data and can read it, and you can view it. This is one thing that we have to improve: the security of the data sent by APRS network. How to make sure that this is secure, right? So many things that we can improve, even though we are using a mix of both, not really old, we should say legacy technology, right? A legacy technology is a technology that may exist for a certain time, but still usable, right? Something like that. Does it answer the questions?
Yes, I think so. Right. Thank you, Dr. Adit. Okay. Next question is for Dr. Yoneyama, and the question is: ASB is not a cheap vehicle. Were you consider or have you considered to use an alternative way to study the air-sea interactions?
Yeah, I agree. It is not a cheap one, a very expensive one. However, however, even so much cheaper than the using a research vessel or deploying a mooring system. But frankly, we are also trying to use, for example, the surface drifter. Right now, we are collaborating with the French Currents to deploy the surface drifter. However, they measure only the surface temperature and the surface salinity. They cannot measure the surface wind component or any other things. So I think the key is the 2 point. One is the we should combine those area, those instruments. Of course, one mooring system, and but we need to make a decision on where is the most effective area to cover or represent those condition of those area. Then for example, we deploy the mooring system, but we deploy the 1 or 2 wave grader or some other such as ASB around or some area. And also we deploy several cheaper surface drifter. And another point is we need to develop the tight relationship between the surface salinity and temperature and, for example, the wind component and or precipitation. Because of course salinity directly influenced by the precipitation and also the such a basically drifter. So that's why it belong to as far as if we know that such a drifting component also depend on the 2 components. One is of course ocean current. The other is also some influence from the wind. And if we can develop find any relationship between the salinity temperature and wind, yeah, we can speculate this one. But if so, however, it cannot be used for the validation for satellite data. So that's a very big problem. But anyway, that is the one idea to use. Computation is maybe the one idea, and although we try to look for another cheaper instrument to measure the AC condition, but there are many obstacles so far. That's all.
Okay.
It's okay.
Yes, thank you very much. And the next question, the next 2 questions are for Mr. Siagian. The first one is: drone is flight in the distance. How about the accuracy that you can deliver to the client, and based on drone types that the drone have? I think that it's asking for the accuracy or about the positioning, and also the types for that the drone available. Yeah.
Okay, I will answer it first. Yeah, yeah. So, yeah, what I can understand, a flight in the distance, maybe like a beyond visual line of sight, or maybe like a maybe operation above like 5 kilometers from the home coordinates. So the accuracy, basically, we are referring to what the client wants, what the client requires, or stated at the very first at the requirements. So, for example, like LiDAR, sometimes it's requested like a 10 to 15 centimeters, and for orthophoto, it's like a 20 centimeters, the accuracy. And the accuracy alone depends on many variables, many things. For example, like the GPS used in the drones, the sensor, and also the resolution. Like you can not have accuracy better than the resolution. For example, like if you point like the GCP or the ground control points, which has resolution of 5 centimeter. Yeah, that's the best you have. But sometimes it's lower, of course. Yeah, like 10 centimeters So many things involved here, many things correlate to the accuracy. And for the drone types we use, well, we add also ground, as I mentioned, also we also use ground survey to increase the accuracy. We put like a ground control points for photogrammetry, and also like a ground control boxes for LiDAR. Yeah, and that's to increase accuracy and to check also using the independent checkpoints. Yeah, but everything comes back to the requirements itself. Yeah, to answer your question in short, maybe you can say like a 10 to 15 centimeters for LiDAR, and for photo it's like a 10 to 30 centimeters. Yeah, and another thing, the consistency of the accuracy, it's quite fluctuative for drones, and yeah, we might it might require like further studies for that, for the consistencies. That's it, Bu.
Great, thank you. And the next question is how reliable the battery efficiency, angle of data collection, and also corrections that needs to be done.
Yeah, for reliability, maybe for the physical condition, like the battery, the drone unit itself, it's quite reliable. But first, you have to know your equipment you're using. Like, for example, there's a flight cycle limitations before you do maintenance. Yeah, and the battery, like how many maximum flight cycles to operate properly. You have to be aware of that first before operating drone, and also the safety factors. Yeah, and that's, but another limitation of using drones probably like outside the operation itself. Like for example, for charging the batteries, you have to have like a reliable power source. Also, sometimes we don't get it in the remote area. Yeah, it's quite challenging. Yeah. And yeah, for angle of data collection and distance correction factors, yeah, maybe it could relate to the accuracy. And because we depends on the, I mean, like for angle of data collection, it's quite various. I mean, it's not really standardized. As I said, like we require like a more standardized output, but up until now, it's handled by the software, yeah, to provide the good required as required accuracies and errors. Yeah, I think.
All right. Okay. Thank you, Mr. Siagian. So that concludes the speaking section or the presentation by distinguished speaker this morning. I would like to thank Dr. Imade Andi Arsana, Professor Kazuo Ochi, Dr. Anindya Wirasatria, Mr. Michael Wisnuwardana, Dr. Yudi Aditya Warman, Mr. Yudi Anantasena, Dr. Kunio Yonayama, and Dr. Dian Malati. Thank you very much for a very interesting morning with various applications of remote sensing and geosciences. With that, I would like to return the mic to Master of Ceremony. Thank you again.
Okay, thank you, Dr. Marina, for become our moderator, and also thank you for our speakers for this session. Ladies and gentlemen, we would like to inform you the following matters. The first is a next session for attendees. Please break until 13:30 and followed by parallel sessions.
For parallel session, will be shared in some breakout rooms. Please kindly see your email to know about the session location and time.
And don't forget, at the end of conference, we will announce the best paper and the best presenter award. Thank you very much.
And see you on the parallel session after break.
Sejarah riset dan ilmu pengetahuan Republik Indonesia dimulai sejak tahun 1948, yaitu sejak kelahiran Organisasi Penyelidikan Ilmu Pengetahuan Alam atau OPIPA. 8 tahun kemudian, lahirlah sebuah lembaga riset bernama Majelis Ilmu Pengetahuan Indonesia atau MIPI. Lembaga ini lahir atas permintaan Presiden Soekarno kepada Sarwono Prawiro Harjo yang kemudian menjabat sebagai Ketua MIPI. Sarwono Prawiro Harjo memiliki banyak andil dalam membangun lembaga keilmuan di Indonesia. Tak hanya MIPI, dokter dan guru besar ilmu kebidanan ini juga membantu lahirnya berbagai organisasi profesi kedokteran. Sarwono dikenal mampu mengembangkan berbagai cabang ilmu pengetahuan, sekaligus memimpin para ilmuwan dalam sebuah harmonisasi ilmiah. Ketika teknologi atom atau nuklir mulai populer, pemerintah Indonesia berusaha mengembangkannya dengan tujuan damai serta kesejahteraan masyarakat. Hal itu diwujudkan dengan pembentukan Dewan Tenaga Atom dan Lembaga Tenaga Atom. Lembaga tersebut kemudian disempurnakan menjadi Badan Tenaga Atom Nasional atau BATAN. Tonggak penting penelitian dan pengembangan tenaga atom lainnya ialah peresmian reaktor atom pertama, yaitu reaktor Triga Mark II di Bandung. Masih terbatasnya ilmuwan pada berbagai bidang teknologi juga menjadi salah satu perhatian besar Presiden Soekarno. Melalui program beasiswa Ikatan Dinas, pemerintahan Presiden Soekarno mengirim ribuan pelajar untuk melanjutkan studi di berbagai negara. Sebuah tonggak dalam perencanaan pembangunan hadir dengan ditetapkannya garis-garis besar pola pembangunan nasional sistem semesta berencana. Di dalamnya terkandung perencanaan IPTEK yang dikenal sebagai Visi IPTEK 1961-1969. Saat itu, Presiden Soekarno menyampaikan bahwa MIPI harus segera diubah menjadi Badan Penelitian Nasional. Menurutnya, lebih baik hanya ada satu lembaga IPTEK tertinggi di Indonesia. Hal ini untuk menghindari tumpang tindih dan pemborosan anggaran. Untuk memperkuat sisi kelembagaan, pemerintah kemudian membentuk Departemen Urusan Riset Nasional atau Durenas yang dipimpin Sujono Junet Pusponegoro. Posisi MIPI kemudian menjadi di bawah naungan Durenas dengan tugas tambahan membangun serta mengasuh beberapa lembaga riset nasional. Sarwono Prawiro Harjo sebagai Ketua MIPI juga diberi tanggung jawab ganda sebagai Deputi Menteri Riset. Sementara itu, pengembangan teknologi kedirgantaraan nasional dimulai dengan dibentuknya Panitia Astronautika oleh Perdana Menteri Juanda. Keberhasilan proyek roket yang melibatkan perguruan tinggi dan militer ini kemudian dilanjutkan dengan membentuk Lembaga Penerbangan dan Antariksa Nasional atau LAPAN. Pada tahun yang sama, pemerintah juga membangun National Research Center Cibinong. Gunanya untuk mewadahi bermacam fasilitas riset di berbagai bidang ilmu pengetahuan. Perubahan kelembagaan berlangsung dinamis pada pertengahan tahun 60-an. Hal tersebut diawali dengan penggantian dan perubahan status Durenas menjadi Lembaga Riset Nasional atau Lemrenas. Tahun berikutnya, pemerintah membubarkan Lemrenas dan MIPI, lalu membentuk Lembaga Ilmu Pengetahuan Indonesia atau LIPI yang dikepalai oleh Sarwono Prawiro Harjo. Aktivitas riset dan pengembangan IPTEK kembali menggeliat ketika pemerintah menunjuk Sumitro Joyo Hadikusumo sebagai Menteri Negara Riset. Ia berkolaborasi dengan B.J. Habibie untuk merintis pembangunan industri pesawat dalam negeri, kawasan riset terpadu, serta sebuah badan pengembangan teknologi. Kawasan riset terpadu dan terbesar di Indonesia berhasil terwujud dengan didirikannya Pusat Penelitian Ilmu Pengetahuan dan Teknologi atau Puspitek. Di kawasan ini pula, kemudian dibangun reaktor nuklir serbaguna, GA Siwabesi. Reaktor nuklir berkapasitas 30 MW ini merupakan yang terbesar di Asia Tenggara. Sebuah institusi untuk mengembangkan dan mendayagunakan teknologi kemudian juga dapat terimplementasikan dengan pendirian Badan Pengkajian dan Penerapan Teknologi atau BPPT. Pada saat bersamaan, B.J. Habibie juga dilantik menjadi Menteri Negara Riset dan Teknologi, Kepala Badan Pengkajian dan Penerapan Teknologi. Ilmuwan dan negarawan, seperti itulah masyarakat dunia mengenal B.J. Habibie, pakar aeronautika yang sedang berada di puncak karir internasional, namun bersedia kembali untuk membangun negeri. Ia terbukti mampu membawa Indonesia menuju era tinggal landas dengan mengorkestrasi pembangunan di bidang riset dan teknologi. Semangat dan kerja keras untuk selalu menghadirkan inovasi membawa pengabdiannya mencapai posisi puncak di negeri ini. Pemerintah juga sempat mendirikan Dewan Riset Nasional. Melalui lembaga non-struktural ini, digali pemikiran dan pemandangan dari pihak-pihak yang berkepentingan dengan perkembangan iptek di Indonesia. Di tengah derap laju pembangunan, Indonesia masih menyisakan persoalan pada bidang sumber daya manusia. Saat itu, rasio antara insinyur dan penduduk masih terlalu rendah. B.J. Habibie melakukan terobosan dengan menggelar serangkaian program beasiswa ke luar negeri. Program yang sukses dilaksanakan hingga puluhan tahun ini dikelola oleh Pusat Pendidikan dan Latihan BPPT. Pada dekade 80-an, Indonesia mulai banyak mengembangkan industri berbasis teknologi maju. Untuk membangun pola manajemen yang lebih terintegrasi, didirikanlah Badan Pengelola Industri Strategis atau BPIS. BPIS membawahi 10 perusahaan di bidang kedirgantaraan, kemaritiman, metalurgi, transportasi, telekomunikasi, dan elektronika. Pada era Habibie, beberapa hal yang sempat terhenti kembali dibangkitkan, seperti ide lama untuk mendirikan Akademi Ilmu Pengetahuan Indonesia atau IP yang akhirnya dapat terwujud. Kemudian juga dengan dibukanya kembali Lembaga Biologi Molekuler Eijkman yang sempat ditutup pada tahun 60-an. Lembaga yang didirikan ilmuwan Belanda penerima Nobel ini memiliki fokus utama dalam memajukan penelitian dasar dan terapan di bidang biologi molekuler. Puncak keemasan teknologi Indonesia terjadi pada 50 tahun setelah kemerdekaan, tepatnya pada 10 Agustus 1995. Saat pesawat N250 sukses melakukan penerbangan perdana di Bandung. Mengudaranya pesawat yang dirancang dan dibangun sepenuhnya oleh anak bangsa ini menjadi sebuah tonggak sejarah yang kemudian diabadikan sebagai Hari Kebangkitan Teknologi Nasional atau Hakteknas. Memasuki milenia kedua, untuk melompat dan mengejar ketertinggalan dari bangsa lain, terbitlah Undang-Undang Sisnas P3 Iptek. Undang-undang ini menyebutkan kelembagaan ilmu pengetahuan dan teknologi, terdiri atas unsur perguruan tinggi, lembaga penelitian dan pengembangan, badan usaha, dan lembaga penunjang. Sebuah pendekatan untuk meningkatkan kemajuan iptek dengan melibatkan perguruan tinggi sempat dilakukan melalui penggabungan antara Kementerian Riset dan Teknologi dengan Direktorat Jenderal Pendidikan Tinggi. Kemenristek Dikti mewadahi terciptanya inovasi dengan mensinergiskan dunia riset dan dunia kampus, termasuk mendorong hilirisasi hasil riset pada ekosistem industri. 5 tahun berselang, lahir Undang-Undang Sisnas Iptek sebagai pengganti undang-undang yang terbit di tahun 2002. Undang-undang baru ini mengamanatkan pembentukan Badan Riset dan Inovasi Nasional atau BRIN. Badan yang didirikan untuk memastikan ekosistem riset nasional berjalan lebih baik dan maksimal ini ditindaklanjuti dengan Peraturan Presiden tentang pembentukan Kemristek BRIN. tantangan utama yang langsung dihadapi Kemristek BRAIN ialah merebaknya pandemi COVID-19. Sebagai respon, dibentuklah Konsorsium Riset dan Inovasi COVID-19. Fokus utamanya memberikan solusi terhadap wabah, sekaligus meningkatkan kemandirian bangsa melalui kolaborasi dengan berbagai lembaga. Produk inovasi yang hingga kini terus dikembangkan ialah vaksin merah putih. BRAIN telah ditetapkan sebagai badan otonom yang bertanggung jawab langsung kepada Presiden. Hal ini dibarengi dengan pelantikan Laksana Trihandoko sebagai Kepala Badan Riset dan Inovasi Nasional oleh Presiden Joko Widodo. BRAIN mengintegrasikan 4 lembaga riset, yaitu LIPI, BPPT, BATA, dan LAPAN, termasuk mengkoordinir riset yang dilakukan oleh Litbang Kementerian serta Balitbang daerah di seluruh Indonesia. Keberadaan BRAIN diharapkan dapat membuat alur koordinasi riset lebih efektif dan efisien, sebagaimana amanat yang pernah disampaikan Presiden Soekarno tentang lembaga iptek tertinggi di Indonesia.
Benua maritim Indonesia yang terbentang dari Sabang hingga Merauke merupakan wilayah perairan dengan hamparan pulau-pulau di dalamnya sebagai satu kesatuan alamiah antara darat, laut, dan udara. Sebagai negara kepulauan yang memiliki potensi sumber daya alam hayati dan non-hayati, menjadikan Indonesia sebagai suatu negara yang memiliki peranan penting dan strategis di dunia. Oleh karena itu, Badan Pengkajian dan Penerapan Teknologi hadir untuk mengembangkan teknologi pengelolaan sumber daya alam berbasis kewilayahan. Hal ini diwujudkan melalui adanya Pusat Teknologi Pengembangan Sumber Daya Wilayah atau PTPSW sebagai salah satu unit kerja pada Badan Pengkajian dan Penerapan Teknologi. PTPSW diamanatkan mengembangkan teknologi sumber daya wilayah, yakni teknologi dan aplikasi pengelolaan sumber daya yang berada pada suatu wilayah tertentu untuk mencapai tujuan pengembangan wilayah secara berkelanjutan demi meningkatkan kesejahteraan dan daya saing bangsa. Dengan visi untuk menjadi pusat unggulan teknologi pengembangan sumber daya wilayah yang menghasilkan inovasi dalam peningkatan produktivitas pembangunan nasional, PTPSW terus berkembang secara dinamis dan juga adaptif untuk mengkaji teknologi di bidang pengembangan sumber daya wilayah. Dengan berprinsip pada nilai tematik, integratif, spasial, dan dinamis, PTPSW melakukan tugasnya dengan berbasis teknologi penginderaan jauh maju, teknologi geofisika maju, teknologi akustik tomografi, dan teknologi akuntansi sumber daya alam untuk pengembangan sumber daya wilayah. PTPSW berperan aktif dalam program besar BPPT, yaitu Indonesia Tsunami Early Warning System, melalui kegiatan pemantauan karakteristik rambatan menggunakan sensor akustik tomografi, serta teknologi integrasi dan interoperabilitas data observasi kebumian untuk kesiapsiagaan nasional. Selain itu, PTPSW juga berperan untuk menyukseskan kegiatan sistem informasi zoonosis dan emerging infectious disease. Dalam menjalankan kegiatan sesuai dengan tugas pokok dan fungsi, PTPSW memiliki sumber daya manusia yang unggul, yakni putra-putri terbaik bangsa dari berbagai disiplin ilmu dan juga bidang keahlian. PTPSW juga didukung oleh berbagai sarana dan prasarana seperti fasilitas peralatan survei terestris, peralatan survei laut dan pesisir, wahana survei, radar cuaca, penggunaan perangkat lunak, dan fasilitas sistem pemantauan observasi kebumian Nusantara atau Nusantara Earth Observation Network atau NEONET. Selain itu, PT PSW juga telah berhasil menghasilkan karya-karya inovasi, solusi, dan layanan teknologi hasil karya anak bangsa. Salah satunya adalah kerangka sampel area atau KSA, suatu metode untuk menentukan luas panen padi guna mendapatkan data produksi padi yang lebih akurat dan tepat. Teknologi ini telah dimanfaatkan oleh Badan Pusat Statistik. Untuk menjalankan perannya dalam intermediasi teknologi, PT PSW berkoordinasi dengan berbagai lembaga pemerintahan, juga memiliki jaringan mitra kerjasama yang luas baik di dalam negeri maupun luar negeri.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan salam sehat untuk kita semua. Kami, keluarga besar Pusat Teknologi Pengembangan Sumber Daya Wilayah Badan Pengkajian dan Penerapan Teknologi, tetap berupaya untuk menguasai dan berburu inovasi teknologi-teknologi terkait dengan kewilayahan, data spasial dan informasi geospasial berbasis teknologi-teknologi canggih yang berbasis industri 4.0. Kepada teman-teman PT PSW juga kami serukan supaya tetap semangat, tetap berkarya dalam menguasai teknologi tersebut dan mengaplikasikan ke dalam pembangunan nasional kita. Terima kasih.
Sejarah riset dan ilmu pengetahuan Republik Indonesia dimulai sejak tahun 1948, yaitu sejak kelahiran Organisasi Penyelidikan Ilmu Pengetahuan Alam atau OPIPA. 8 tahun kemudian, lahirlah sebuah lembaga riset bernama Majelis Ilmu Pengetahuan Indonesia atau MIPI. Lembaga ini lahir atas permintaan Presiden Soekarno kepada Sarwono Prawiro Harjo yang kemudian menjabat sebagai Ketua MIPI. Sarwono Prawiro Harjo memiliki banyak andil dalam membangun lembaga keilmuan di Indonesia. Tak hanya MIPI, dokter dan guru besar ilmu kebidanan ini juga membantu lahirnya berbagai organisasi profesi kedokteran. Sarwono dikenal mampu mengembangkan berbagai cabang ilmu pengetahuan, sekaligus memimpin para ilmuwan dalam sebuah harmonisasi ilmiah. Ketika teknologi atom atau nuklir mulai populer, pemerintah Indonesia berusaha mengembangkannya dengan tujuan damai serta kesejahteraan masyarakat. Hal itu diwujudkan dengan pembentukan Dewan Tenaga Atom dan Lembaga Tenaga Atom. Lembaga tersebut kemudian disempurnakan menjadi Badan Tenaga Atom Nasional atau BATAN. Tonggak penting penelitian dan pengembangan tenaga atom lainnya ialah peresmian reaktor atom pertama, yaitu reaktor Triga Mark II di Bandung. Masih terbatasnya ilmuwan pada berbagai bidang teknologi juga menjadi salah satu perhatian besar Presiden Soekarno. Melalui program beasiswa Ikatan Dinas, pemerintahan Presiden Soekarno mengirim ribuan pelajar untuk melanjutkan studi di berbagai negara. Sebuah tonggak dalam perencanaan pembangunan hadir dengan ditetapkannya garis-garis besar pola pembangunan nasional sistem semesta berencana. Di dalamnya terkandung perencanaan IPTEK yang dikenal sebagai Visi IPTEK 1961-1969. Saat itu, Presiden Soekarno menyampaikan bahwa MIPI harus segera diubah menjadi Badan Penelitian Nasional. Menurutnya, lebih baik hanya ada satu lembaga IPTEK tertinggi di Indonesia. Hal ini untuk menghindari tumpang tindih dan pemborosan anggaran. Untuk memperkuat sisi kelembagaan, pemerintah kemudian membentuk Departemen Urusan Riset Nasional atau Durenas yang dipimpin Sujono Junet Pusponegoro. Posisi MIPI kemudian menjadi di bawah naungan Durenas dengan tugas tambahan membangun serta mengasuh beberapa lembaga riset nasional. Sarwono Prawiro Harjo sebagai Ketua MIPI juga diberi tanggung jawab ganda sebagai Deputi Menteri Riset. Sementara itu, pengembangan teknologi kedirgantaraan nasional dimulai dengan dibentuknya Panitia Astronautika oleh Perdana Menteri Juanda. Keberhasilan proyek roket yang melibatkan perguruan tinggi dan militer ini kemudian dilanjutkan dengan membentuk Lembaga Penerbangan dan Antariksa Nasional atau LAPAN. Pada tahun yang sama, pemerintah juga membangun National Research Center Cibinong. Gunanya untuk mewadahi bermacam fasilitas riset di berbagai bidang ilmu pengetahuan. Perubahan kelembagaan berlangsung dinamis pada pertengahan tahun 60-an. Hal tersebut diawali dengan penggantian dan perubahan status Durenas menjadi Lembaga Riset Nasional atau Lemrenas. Tahun berikutnya, pemerintah membubarkan Lemrenas dan MIPI, lalu membentuk Lembaga Ilmu Pengetahuan Indonesia atau LIPI yang dikepalai oleh Sarwono Prawiro Harjo. Aktivitas riset dan pengembangan IPTEK kembali menggeliat ketika pemerintah menunjuk Sumitro Joyo Hadikusumo sebagai Menteri Negara Riset. Ia berkolaborasi dengan B.J. Habibie untuk merintis pembangunan industri pesawat dalam negeri, kawasan riset terpadu, serta sebuah badan pengembangan teknologi. Kawasan riset terpadu dan terbesar di Indonesia berhasil terwujud dengan didirikannya Pusat Penelitian Ilmu Pengetahuan dan Teknologi atau Puspitek. Di kawasan ini pula kemudian dibangun reaktor nuklir serbaguna GA Siwabesi. Reaktor nuklir berkapasitas 30 MW ini merupakan yang terbesar di Asia Tenggara. Sebuah institusi untuk mengembangkan dan mendayagunakan teknologi kemudian juga dapat terimplementasikan dengan pendirian Badan Pengkajian dan Penerapan Teknologi atau BPPT. Pada saat bersamaan, B.J. Habibie juga dilantik menjadi Menteri Negara Riset dan Teknologi, Kepala Badan Pengkajian dan Penerapan Teknologi. Ilmuwan dan negarawan, seperti itulah masyarakat dunia mengenal B.J. Habibie, pakar aeronautika yang sedang berada di puncak karir internasional, namun bersedia kembali untuk membangun negeri. Ia terbukti mampu membawa Indonesia menuju era tinggal landas dengan mengorkestrasi pembangunan di bidang riset dan teknologi. Semangat dan kerja keras untuk selalu menghadirkan inovasi membawa pengabdiannya mencapai posisi puncak di negeri ini. Pemerintah juga sempat mendirikan pemandangan dari pihak-pihak yang berkepentingan dengan perkembangan iptek di Indonesia. Di tengah derap laju pembangunan, Indonesia masih menyisakan persoalan pada bidang sumber daya manusia. Saat itu, rasio antara insinyur dan penduduk masih terlalu rendah. B.J. Habibie melakukan terobosan dengan menggelar serangkaian program beasiswa ke luar negeri. Program yang sukses dilaksanakan hingga puluhan tahun ini dikelola oleh Pusat Pendidikan dan Latihan BPPT. Pada dekade 80-an, Indonesia mulai banyak mengembangkan industri berbasis teknologi maju. Untuk membangun pola manajemen yang lebih terintegrasi, didirikanlah Badan Pengelola Industri Strategis atau BPIS. BPIS membawahi 10 perusahaan di bidang kedirgantaraan, kemaritiman, metalurgi, transportasi, telekomunikasi, dan elektronika. Pada era Habibie, beberapa hal yang sempat terhenti kembali dibangkitkan, seperti ide lama untuk mendirikan Akademi Ilmu Pengetahuan Indonesia atau IP yang akhirnya dapat terwujud. Kemudian juga dengan dibukanya kembali Lembaga Biologi Molekuler Eijkman yang sempat ditutup pada tahun 60-an. Lembaga yang didirikan ilmuwan Belanda penerima Nobel ini memiliki fokus utama dalam memajukan penelitian dasar dan terapan di bidang biologi molekuler. Puncak keemasan teknologi Indonesia terjadi pada 50 tahun setelah kemerdekaan, tepatnya pada 10 Agustus 1995. Saat pesawat N250 sukses melakukan penerbangan perdana di Bandung. Mengudaranya pesawat yang dirancang dan dibangun sepenuhnya oleh anak bangsa ini menjadi sebuah tonggak sejarah yang kemudian diabadikan sebagai Hari Kebangkitan Teknologi Nasional atau Hakteknas. Memasuki milenia kedua, untuk melompat dan mengejar ketertinggalan dari bangsa lain, terbitlah Undang-Undang Sisnas P3 Iptek. Undang-undang ini menyebutkan kelembagaan ilmu pengetahuan dan teknologi, terdiri atas unsur perguruan tinggi, lembaga penelitian dan pengembangan, badan usaha, dan lembaga penunjang. Sebuah pendekatan untuk meningkatkan kemajuan iptek dengan melibatkan perguruan tinggi sempat dilakukan melalui penggabungan antara Kementerian Riset dan Teknologi dengan Direktorat Jenderal Pendidikan Tinggi. Kemenristek Dikti mewadahi terciptanya inovasi dengan mensinergiskan dunia riset dan dunia kampus, termasuk mendorong hilirisasi hasil riset pada ekosistem industri. 5 tahun berselang, lahir Undang-Undang Sisnas Iptek sebagai pengganti undang-undang yang terbit di tahun 2002. Undang-undang baru ini mengamanatkan pembentukan Badan Riset dan Inovasi Nasional atau BRIN. Badan yang didirikan untuk memastikan ekosistem riset nasional berjalan lebih baik dan maksimal ini ditindaklanjuti dengan peraturan Presiden tentang pembentukan Kemristek BRIN. Tantangan utama yang langsung dihadapi Kemristek BRAIN ialah merebaknya pandemi COVID-19. Sebagai respon, dibentuklah Konsorsium Riset dan Inovasi COVID-19. Fokus utamanya memberikan solusi terhadap wabah sekaligus meningkatkan kemandirian bangsa melalui kolaborasi dengan berbagai lembaga. Produk inovasi yang hingga kini terus dikembangkan ialah vaksin merah putih. BRAIN telah ditetapkan sebagai badan otonom yang bertanggung jawab langsung kepada Presiden. Hal ini dibarengi dengan pelantikan Laksana Trihandoko sebagai Kepala Badan Riset dan Inovasi Nasional oleh Presiden Joko Widodo. BRAIN mengintegrasikan 4 lembaga riset, yaitu LIPI, BPPT, BATA, dan LAPAN, termasuk mengkoordinir riset yang dilakukan oleh Litbang Kementerian serta Balitbang daerah di seluruh Indonesia. Keberadaan BRAIN diharapkan dapat membuat alur koordinasi riset lebih efektif dan efisien, sebagaimana amanat yang pernah disampaikan Presiden Soekarno tentang lembaga iptek tertinggi di Indonesia.
Benua maritim Indonesia yang terbentang dari Sabang hingga Merauke merupakan wilayah perairan dengan hamparan pulau-pulau di dalamnya sebagai satu kesatuan alamiah antara darat, laut, dan udara. Sebagai negara kepulauan yang memiliki potensi sumber daya alam hayati dan non-hayati, menjadikan Indonesia sebagai suatu negara yang memiliki peranan penting dan strategis di dunia. Oleh karena itu, Badan Pengkajian dan Penerapan Teknologi hadir untuk mengembangkan teknologi pengelolaan sumber daya alam berbasis kewilayahan. Hal ini diwujudkan melalui adanya Pusat Teknologi Pengembangan Sumber Daya Wilayah atau PT-PSW sebagai salah satu unit kerja pada Badan Pengkajian dan Penerapan Teknologi. PT-PSW diamanatkan mengembangkan teknologi sumber daya wilayah, yakni teknologi dan aplikasi pengelolaan sumber daya yang berada pada suatu wilayah tertentu untuk mencapai tujuan pengembangan wilayah secara berkelanjutan demi meningkatkan kesejahteraan dan daya saing bangsa. Dengan visi untuk menjadi pusat unggulan teknologi pengembangan sumber daya wilayah yang menghasilkan inovasi dalam peningkatan produktivitas pembangunan nasional, PT-PSW terus berkembang secara dinamis dan juga adaptif untuk mengkaji teknologi di bidang pengembangan sumber daya wilayah. Dengan berprinsip pada nilai tematik, integratif, spasial, dan dinamis, PT-PSW melakukan tugasnya dengan berbasis teknologi penginderaan jauh maju, teknologi geofisika maju, teknologi akustik tomografi, dan teknologi akuntansi sumber daya alam untuk pengembangan sumber daya wilayah. PT-PSW berperan aktif dalam program besar BPPT, yaitu Indonesia Tsunami Early Warning System, melalui kegiatan pemantauan karakteristik rambatan menggunakan sensor akustik tomografi, serta teknologi integrasi dan interoperabilitas data observasi kebumian untuk kesiapsiagaan nasional. Selain itu, PT-PSW juga berperan untuk menyukseskan kegiatan sistem informasi zoonosis dan emerging infectious disease. Dalam menjalankan kegiatan sesuai dengan tugas pokok dan fungsi, PT-PSW memiliki sumber daya manusia yang unggul, yakni putra-putri terbaik bangsa dari berbagai disiplin ilmu dan juga bidang keahlian. PT-PSW juga didukung oleh berbagai sarana dan prasarana seperti fasilitas peralatan survei terestris, peralatan survei laut dan pesisir, wahana survei, radar cuaca, penggunaan perangkat lunak, dan fasilitas sistem pemantauan observasi kebumian Nusantara atau Nusantara Earth Observation Network atau NEONET. Selain itu, PT PSW juga telah berhasil menghasilkan karya-karya inovasi, solusi, dan layanan teknologi hasil karya anak bangsa. Salah satunya adalah kerangka sampel area atau KSA, suatu metode untuk menentukan luas panen padi guna mendapatkan data produksi padi yang lebih akurat dan tepat. Teknologi ini telah dimanfaatkan oleh Badan Pusat Statistik. Untuk menjalankan perannya dalam intermediasi teknologi, PT PSW berkoordinasi dengan berbagai lembaga pemerintahan, juga memiliki jaringan mitra kerjasama yang luas baik di dalam negeri maupun luar negeri.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan salam sehat untuk kita semua. Kami, keluarga besar Pusat Teknologi Pengembangan Sumber Daya Wilayah Badan Pengkajian dan Penerapan Teknologi, tetap berupaya untuk menguasai dan berburu inovasi teknologi-teknologi terkait dengan kewilayahan, data spasial dan informasi geospasial berbasis teknologi-teknologi canggih yang berbasis industri 4.0. Kepada teman-teman PT PSW juga kami serukan supaya tetap semangat, tetap berkarya dalam menguasai teknologi tersebut dan mengaplikasikan ke dalam pembangunan nasional kita. Terima kasih.
Sejarah riset dan ilmu pengetahuan Republik Indonesia dimulai sejak tahun 1948, yaitu sejak kelahiran Organisasi Penyelidikan Ilmu Pengetahuan Alam atau OPIPA. 8 tahun kemudian, lahirlah sebuah lembaga riset bernama Majelis Ilmu Pengetahuan Indonesia atau MIPI. Lembaga ini lahir atas permintaan Presiden Soekarno kepada Sarwono Prawiro Harjo yang kemudian menjabat sebagai Ketua MIPI. Sarwono Prawiro Harjo memiliki banyak andil dalam membangun lembaga keilmuan di Indonesia. Tak hanya MIPI, dokter dan guru besar ilmu kebidanan ini juga membantu lahirnya berbagai organisasi profesi kedokteran. Sarwono dikenal mampu mengembangkan berbagai cabang ilmu pengetahuan, sekaligus memimpin para ilmuwan dalam sebuah harmonisasi ilmiah. Ketika teknologi atom atau nuklir mulai populer, pemerintah Indonesia berusaha mengembangkannya dengan tujuan damai serta kesejahteraan masyarakat. Hal itu diwujudkan dengan pembentukan Dewan Tenaga Atom dan Lembaga Tenaga Atom. Lembaga tersebut kemudian disempurnakan menjadi Badan Tenaga Atom Nasional atau BATAN. Tonggak penting penelitian dan pengembangan tenaga atom lainnya ialah peresmian reaktor atom pertama, yaitu reaktor Triga Mark II di Bandung. Masih terbatasnya ilmuwan pada berbagai bidang teknologi juga menjadi salah satu perhatian besar Presiden Soekarno. Melalui program beasiswa Ikatan Dinas, pemerintahan Presiden Soekarno mengirim ribuan pelajar untuk melanjutkan studi di berbagai negara. Sebuah tonggak dalam perencanaan pembangunan hadir dengan ditetapkannya garis-garis besar pola pembangunan nasional sistem semesta berencana. Di dalamnya terkandung perencanaan IPTEK yang dikenal sebagai Visi IPTEK 1961-1969. Saat itu, Presiden Soekarno menyampaikan bahwa MIPI harus segera diubah menjadi Badan Penelitian Nasional. Menurutnya, lebih baik hanya ada satu lembaga IPTEK tertinggi di Indonesia. Hal ini untuk menghindari tumpang tindih dan pemborosan anggaran. Untuk memperkuat sisi kelembagaan, pemerintah kemudian membentuk Departemen Urusan Riset Nasional atau Durenas yang dipimpin Sujono Junet Pusponegoro. Posisi MIPI kemudian menjadi di bawah naungan Durenas dengan tugas tambahan membangun serta mengasuh beberapa lembaga riset nasional. Sarwono Prawiro Harjo sebagai Ketua MIPI juga diberi tanggung jawab ganda sebagai Deputi Menteri Riset. Sementara itu, pengembangan teknologi kedirgantaraan nasional dimulai dengan dibentuknya Panitia Astronautika oleh Perdana Menteri Juanda. Keberhasilan proyek roket yang melibatkan perguruan tinggi dan militer ini kemudian dilanjutkan dengan membentuk Lembaga Penerbangan dan Antariksa Nasional atau LAPAN. Pada tahun yang sama, pemerintah juga membangun National Research Center Cibinong. Gunanya untuk mewadahi bermacam fasilitas riset di berbagai bidang ilmu pengetahuan. Perubahan kelembagaan berlangsung dinamis pada pertengahan tahun 60-an. Hal tersebut diawali dengan penggantian dan perubahan status Durenas menjadi Lembaga Riset Nasional atau Lemrenas. Tahun berikutnya, pemerintah membubarkan Lemrenas dan MIPI, lalu membentuk Lembaga Ilmu Pengetahuan Indonesia atau LIPI yang dikepalai oleh Sarwono Prawiro Harjo. Aktivitas riset dan pengembangan IPTEK kembali menggeliat ketika pemerintah menunjuk Sumitro Joyo Hadikusumo sebagai Menteri Negara Riset. Ia berkolaborasi dengan B.J. Habibie untuk merintis pembangunan industri pesawat dalam negeri, kawasan riset terpadu, serta sebuah badan pengembangan teknologi. Kawasan riset terpadu dan terbesar di Indonesia berhasil terwujud dengan didirikannya Pusat Penelitian Ilmu Pengetahuan dan Teknologi atau Puspitek. Di kawasan ini pula kemudian dibangun reaktor nuklir serbaguna GA Siwabesi. Reaktor nuklir berkapasitas 30 MW ini merupakan yang terbesar di Asia Tenggara. Sebuah institusi untuk mengembangkan dan mendayagunakan teknologi, kemudian juga dapat terimplementasikan dengan pendirian Badan Pengkajian dan Penerapan Teknologi atau BPPT. Pada saat bersamaan, B.J. Habibie juga dilantik menjadi Menteri Negara Riset dan Teknologi, Kepala Badan Pengkajian dan Penerapan Teknologi. Ilmuwan dan negarawan, seperti itulah masyarakat dunia mengenal B.J. Habibie, pakar aeronautika yang sedang berada di puncak karir internasional, namun bersedia kembali untuk membangun negeri. Ia terbukti mampu membawa Indonesia menuju era tinggal landas dengan mengorkestrasi pembangunan di bidang riset dan teknologi. Semangat dan kerja keras untuk selalu menghadirkan inovasi membawa pengabdiannya mencapai posisi puncak di negeri ini. Pemerintah juga sempat mendirikan Dewan Riset Nasional. Melalui lembaga non-struktural ini, digali pemikiran dan pemandangan dari pihak-pihak yang berkepentingan dengan perkembangan iptek di Indonesia. Di tengah derap laju pembangunan, Indonesia masih menyisakan persoalan pada bidang sumber daya manusia. Saat itu, rasio antara insinyur dan penduduk masih terlalu rendah. B.J. Habibie melakukan terobosan dengan menggelar serangkaian program beasiswa ke luar negeri. Program yang sukses dilaksanakan hingga puluhan tahun ini dikelola oleh Pusat Pendidikan dan Latihan BPPT. Pada dekade 80-an, Indonesia mulai banyak mengembangkan industri berbasis teknologi maju. Untuk membangun pola manajemen yang lebih terintegrasi, didirikanlah Badan Pengelola Industri Strategis atau BPIS. BPIS membawahi 10 perusahaan di bidang kedirgantaraan, kemaritiman, metalurgi, transportasi, telekomunikasi, dan elektronika. Pada era Habibie, beberapa hal yang sempat terhenti kembali dibangkitkan, seperti ide lama untuk mendirikan Akademi Ilmu Pengetahuan Indonesia atau IP yang akhirnya dapat terwujud. Kemudian juga dengan dibukanya kembali Lembaga Biologi Molekuler Eijkman yang sempat ditutup pada tahun 60-an. Lembaga yang didirikan ilmuwan Belanda penerima Nobel ini memiliki fokus utama dalam memajukan penelitian dasar dan terapan di bidang biologi molekuler. Puncak keemasan teknologi Indonesia terjadi pada 50 tahun setelah kemerdekaan, tepatnya pada 10 Agustus 1995. Saat pesawat N250 sukses melakukan penerbangan perdana di Bandung. Mengudaranya pesawat yang dirancang dan dibangun sepenuhnya oleh anak bangsa ini menjadi sebuah tonggak sejarah yang kemudian diabadikan sebagai Hari Kebangkitan Teknologi Nasional atau Hakteknas. Memasuki milenia kedua untuk melompat dan mengejar ketertinggalan dari bangsa lain, terbitlah Undang-Undang Sisnas P3 Iptek. Undang-undang ini menyebutkan kelembagaan ilmu pengetahuan dan teknologi, terdiri atas unsur perguruan tinggi, lembaga penelitian dan pengembangan, badan usaha, dan lembaga penunjang. Sebuah pendekatan untuk meningkatkan kemajuan iptek dengan melibatkan perguruan tinggi sempat dilakukan melalui penggabungan antara Kementerian Riset dan Teknologi dengan Direktorat Jenderal Pendidikan Tinggi. Kemenristek Dikti mewadahi terciptanya inovasi dengan mensinergiskan dunia riset dan dunia kampus, termasuk mendorong hilirisasi hasil riset pada ekosistem industri. 5 tahun berselang, lahir Undang-Undang Sisnas Iptek sebagai pengganti undang-undang yang terbit di tahun 2002. Undang-undang baru ini mengamanatkan pembentukan Badan Riset dan Inovasi Nasional atau BRIN. Badan yang didirikan untuk memastikan ekosistem riset nasional berjalan lebih baik dan maksimal ini ditindaklanjuti dengan peraturan Presiden tentang pembentukan Kemristek BRIN. Tantangan utama yang langsung dihadapi Kemristek BRAIN ialah merebaknya pandemi COVID-19. Sebagai respon, dibentuklah Konsorsium Riset dan Inovasi COVID-19. Fokus utamanya memberikan solusi terhadap wabah sekaligus meningkatkan kemandirian bangsa melalui kolaborasi dengan berbagai lembaga. Produk inovasi yang hingga kini terus dikembangkan ialah vaksin merah putih. BRAIN telah ditetapkan sebagai badan otonom yang bertanggung jawab langsung kepada Presiden. Hal ini dibarengi dengan pelantikan Laksana Trihandoko sebagai Kepala Badan Riset dan Inovasi Nasional oleh Presiden Joko Widodo. BRAIN mengintegrasikan 4 lembaga riset, yaitu LIPI, BPPT, BATA, dan LAPAN, termasuk mengkoordinir riset yang dilakukan oleh Litbang Kementerian serta Balitbang daerah di seluruh Indonesia. Keberadaan BRAIN diharapkan dapat membuat alur koordinasi riset lebih efektif dan efisien, sebagaimana amanat yang pernah disampaikan Presiden Soekarno tentang lembaga iptek tertinggi di Indonesia.
Ladies and gentlemen, welcome to the second session of the second day IEEE Asia Pacific Conference on Geoscience, Electronic and Remote Sensing Technology 2021.
Ladies and gentlemen, we would like to inform you the following matters. For parallel sessions will be shared in some breakout rooms. Please kindly see your email to know about sessions location and time.
At the end of the conference, we will announce about the best paper and the best presenter award.
Please pay your attention on your screen for the detail of announcement meeting.
And if you have any difficult to join the breakout rooms for polarization, please raise your hand and the committee will help you. Thank you.
Sejarah riset dan ilmu pengetahuan Republik Indonesia dimulai sejak tahun 1948, yaitu sejak kelahiran Organisasi Penyelidikan Ilmu Pengetahuan Alam atau OPIPA. 8 tahun kemudian, lahirlah sebuah lembaga riset Tak hanya MIPI, dokter dan guru besar ilmu kebidanan ini juga membantu lahirnya berbagai organisasi profesi kedokteran. Sarwono dikenal mampu mengembangkan berbagai cabang ilmu pengetahuan, sekaligus memimpin para ilmuwan dalam sebuah harmonisasi ilmiah. Ketika teknologi atom atau nuklir mulai populer, pemerintah Indonesia berusaha mengembangkannya dengan tujuan damai serta kesejahteraan masyarakat. Hal itu diwujudkan dengan pembentukan Dewan Tenaga Atom dan Lembaga Tenaga Atom. Lembaga tersebut kemudian disempurnakan menjadi Badan Tenaga Atom Nasional atau BATAN. Tonggak penting penelitian dan pengembangan tenaga atom lainnya ialah peresmian reaktor atom pertama, yaitu reaktor Triga Mark II di Bandung. Masih terbatasnya ilmuwan pada berbagai bidang teknologi juga menjadi salah satu perhatian besar Presiden Soekarno. Melalui program beasiswa
Benua maritim Indonesia yang terbentang dari Sabang hingga Merauke merupakan wilayah perairan dengan hamparan pulau-pulau di dalamnya sebagai satu kesatuan alamiah antara darat, laut, dan udara. Sebagai negara kepulauan yang memiliki potensi sumber daya alam hayati dan non-hayati, menjadikan Indonesia sebagai suatu negara yang memiliki peranan penting dan strategis di dunia. Oleh karena itu, Badan Pengkajian dan Penerapan Teknologi hadir untuk mengembangkan teknologi pengelolaan sumber daya alam berbasis kewilayahan. Hal ini diwujudkan melalui adanya Pusat Teknologi Pengembangan Sumber Daya Wilayah atau PT-PSW sebagai salah satu unit kerja pada Badan Pengkajian dan Penerapan Teknologi. PT-PSW diamanatkan mengembangkan teknologi sumber daya wilayah, yakni teknologi dan aplikasi pengelolaan sumber daya yang berada pada suatu wilayah tertentu untuk mencapai tujuan pengembangan wilayah secara berkelanjutan demi meningkatkan kesejahteraan dan daya saing bangsa. Dengan visi untuk menjadi pusat unggulan teknologi pengembangan sumber daya wilayah yang menghasilkan inovasi dalam peningkatan produktivitas pembangunan nasional, PT-PSW terus berkembang secara dinamis dan juga adaptif untuk mengkaji teknologi di bidang pengembangan sumber daya wilayah. Dengan berprinsip pada nilai tematik, integratif, spasial, dan dinamis, PT-PSW melakukan tugasnya dengan berbasis teknologi penginderaan jauh maju, teknologi geofisika maju, teknologi akustik tomografi, dan teknologi akuntansi sumber daya alam untuk pengembangan sumber daya wilayah. PT-PSW berperan aktif dalam program besar BPPT, yaitu Indonesia Tsunami Early Warning System, melalui kegiatan pemantauan karakteristik rambatan menggunakan sensor akustik tomografi, serta teknologi integrasi dan interoperabilitas data observasi kebumian untuk kesiapsiagaan nasional. Selain itu, PT-PSW juga berperan untuk menyukseskan kegiatan sistem informasi zoonosis dan emerging infectious disease. Dalam menjalankan kegiatan sesuai dengan tugas pokok dan fungsi, PT-PSW memiliki sumber daya manusia yang unggul, yakni putra-putri terbaik bangsa dari berbagai disiplin ilmu dan juga bidang keahlian. PT-PSW juga didukung oleh berbagai sarana dan prasarana seperti fasilitas peralatan survei terestris, peralatan survei laut dan pesisir, wahana survei, radar cuaca, penggunaan perangkat lunak, dan fasilitas sistem pemantauan observasi kebumian Nusantara atau Nusantara Earth Observation Network atau NEONET. Selain itu, PT-PSW juga telah berhasil menghasilkan karya-karya inovasi, solusi, dan layanan teknologi hasil karya anak bangsa. Salah satunya adalah kerangka sampel area atau KSA, suatu metode untuk menentukan luas panen padi guna mendapatkan data produksi padi yang lebih akurat dan tepat. Teknologi ini telah dimanfaatkan oleh Badan Pusat Statistik. Untuk menjalankan perannya dalam intermediasi teknologi, PT-PSW berkoordinasi dengan berbagai lembaga pemerintahan, juga memiliki jaringan mitra kerjasama yang luas baik di dalam negeri maupun luar negeri.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan salam sehat untuk kita semua. Kami, keluarga besar Pusat Teknologi Pengembangan Sumber Daya Wilayah Badan Pengkajian dan Penerapan Teknologi, tetap berupaya untuk menguasai dan berburu inovasi teknologi-teknologi terkait dengan kewilayahan, data spasial dan informasi geospasial berbasis teknologi-teknologi canggih yang berbasis industri 4.0. Kepada teman-teman PT-PSW juga kami serukan supaya tetap semangat, tetap berkarya dalam menguasai teknologi tersebut dan mengaplikasikan ke dalam pembangunan nasional kita. Terima kasih.
Benua maritim Indonesia yang terbentang dari Sabang hingga Merauke merupakan wilayah perairan dengan hamparan pulau-pulau di dalamnya sebagai satu kesatuan alamiah antara darat, laut, dan udara. Sebagai negara kepulauan yang memiliki potensi sumber daya alam hayati dan non-hayati, menjadikan Indonesia sebagai suatu negara yang memiliki peranan penting dan strategis di dunia. Oleh karena itu, Badan Pengkajian dan Penerapan Teknologi hadir untuk mengembangkan teknologi pengelolaan sumber daya alam berbasis kewilayahan. Hal ini diwujudkan melalui adanya Pusat Teknologi Pengembangan Sumber Daya Wilayah atau PT-PSW sebagai salah satu unit kerja pada Badan dan Penerapan Teknologi. PT-PSW diamanatkan mengembangkan teknologi sumber daya wilayah, yakni teknologi dan aplikasi pengelolaan sumber daya yang berada pada suatu wilayah tertentu untuk mencapai tujuan pengembangan wilayah secara berkelanjutan demi meningkatkan kesejahteraan dan daya saing bangsa. Dengan visi untuk menjadi pusat unggulan teknologi pengembangan sumber daya wilayah yang menghasilkan inovasi dalam peningkatan produktivitas pembangunan nasional, PT-PSW terus berkembang secara dinamis dan juga adaptif untuk mengkaji teknologi di bidang pengembangan sumber daya wilayah. Dengan berprinsip pada nilai tematik, integratif, spasial, PT-PSW melakukan tugasnya dengan berbasis teknologi penginderaan jauh maju, teknologi geofisika maju, teknologi akustik tomografi, dan teknologi akuntansi sumber daya alam untuk pengembangan sumber daya wilayah. PT-PSW berperan aktif dalam program besar BPPT, yaitu Indonesia Tsunami Early Warning System, melalui kegiatan pemantauan karakteristik rambatan menggunakan sensor akustik tomografi, serta teknologi integrasi dan interoperabilitas data observasi kebumian untuk kesiapsiagaan nasional. Selain itu, PT-PSW juga berperan untuk menyukseskan kegiatan sistem informasi zoonosis dan emerging infectious disease. Dalam menjalankan kegiatan sesuai dengan tugas pokok dan fungsi, PT-PSW memiliki sumber daya manusia yang unggul, yakni putra-putri terbaik bangsa dari berbagai disiplin ilmu dan juga bidang keahlian. PT-PSW juga didukung oleh berbagai sarana dan prasarana seperti fasilitas peralatan survei terestris, peralatan survei laut dan pesisir, wahana survei, radar cuaca, penggunaan perangkat lunak, dan fasilitas sistem pemantauan observasi kebumian Nusantara atau Nusantara Earth Observation Network atau NEONET. Selain itu, PT-PSW juga telah berhasil menghasilkan karya-karya inovasi, solusi, dan layanan teknologi hasil karya anak bangsa. Salah satunya adalah Kerangka Sampel Area atau KSA, suatu metode untuk menentukan luas panen padi guna mendapatkan data produksi padi yang lebih akurat dan tepat. Teknologi ini telah dimanfaatkan oleh Badan Pusat Statistik. Untuk menjalankan perannya dalam intermediasi teknologi, PT-PSW berkoordinasi dengan berbagai lembaga pemerintahan, juga memiliki jaringan mitra kerjasama yang luas baik di dalam negeri maupun luar negeri.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan salam sehat untuk kita semua. Kami, keluarga besar Pusat Teknologi Pengembangan Sumber Daya Wilayah Badan Pengkajian dan Penerapan Teknologi, tetap berupaya untuk menguasai dan berburu inovasi teknologi-teknologi terkait dengan kewilayahan, data spasial dan informasi geospasial berbasis teknologi-teknologi canggih yang berbasis industri 4.0. Kepada teman-teman PT PSW juga kami serukan supaya tetap semangat, tetap berkarya dalam menguasai teknologi tersebut dan mengaplikasikan ke dalam pembangunan nasional kita. Terima kasih.
Benua maritim Indonesia yang terbentang dari Sabang hingga Merauke merupakan wilayah perairan dengan hamparan pulau-pulau di dalamnya sebagai satu kesatuan alamiah antara darat, laut, dan udara. Sebagai negara kepulauan yang memiliki potensi sumber daya alam hayati dan non-hayati, menjadikan Indonesia sebagai suatu negara yang memiliki peranan penting dan strategis di dunia. Oleh karena itu, Badan Pengkajian dan Penerapan Teknologi hadir untuk mengembangkan teknologi pengelolaan sumber daya alam berbasis kewilayahan. Hal ini diwujudkan melalui adanya Pusat Teknologi Pengembangan Sumber Daya Wilayah atau PT PSW sebagai salah satu unit kerja pada Badan Pengkajian dan Penerapan Teknologi. PT PSW diamanatkan mengembangkan teknologi sumber daya wilayah, yakni teknologi dan aplikasi pengelolaan sumber daya yang berada pada suatu wilayah tertentu untuk mencapai tujuan pengembangan wilayah secara berkelanjutan demi meningkatkan kesejahteraan dan daya saing bangsa. Dengan visi untuk menjadi pusat unggulan teknologi pengembangan sumber daya wilayah yang menghasilkan inovasi dalam peningkatan produktivitas pembangunan nasional, PT PSW terus berkembang secara dinamis dan juga adaptif untuk mengkaji teknologi di bidang pengembangan sumber daya wilayah. Dengan berprinsip pada nilai tematik, integratif, spasial, dan dinamis, PT PSW melakukan tugasnya dengan berbasis teknologi penginderaan jauh maju, teknologi geofisika maju, teknologi akustik tomografi, dan teknologi akuntansi sumber daya alam untuk pengembangan sumber daya wilayah. PT PSW berperan aktif dalam program besar BPPT, yaitu Indonesia Tsunami Early Warning System, melalui kegiatan pemantauan karakteristik rambatan menggunakan sensor akustik tomografi, serta teknologi integrasi dan interoperabilitas data observasi kebumian untuk kesiapsiagaan nasional. Selain itu, PT PSW juga berperan untuk menyukseskan kegiatan sistem informasi zoonosis dan emerging infectious disease. Dalam menjalankan kegiatan sesuai dengan tugas pokok dan fungsi, PT PSW memiliki sumber daya manusia yang unggul, yakni putra-putri terbaik bangsa dari berbagai disiplin ilmu dan juga bidang keahlian. PT PSW juga didukung oleh berbagai sarana dan prasarana seperti fasilitas peralatan survei terestris, peralatan survei laut dan pesisir, wahana survei, radar cuaca, penggunaan perangkat lunak, dan fasilitas sistem pemantauan observasi kebumian Nusantara atau Nusantara Earth Observation Network atau NEONET. Selain itu, PT PSW juga telah berhasil menghasilkan karya-karya inovasi, solusi, dan layanan teknologi hasil karya anak bangsa. Salah satunya adalah kerangka sampel area atau KSA, suatu metode untuk menentukan luas panen padi guna mendapatkan data produksi padi yang lebih akurat dan tepat. Teknologi ini telah dimanfaatkan.
Okay, thank you, ladies and gentlemen, for still staying with us. Now we will continue to announce the winner of Best Paper and Best Presenter for this conference. We would like to invite Dr. Arifin Nugroho to announce the winner and give the certificate virtually. The time is yours. Please welcome Dr. Arifin Nugroho.
Bismillahirrahmanirrahim. In this very occasion, the committee has been doing a thorough work and concluding to the papers that merited to be awarded. However, I have to mention that actually every paper has been so presented in this very occasions, in this AGERS 21. First of all, it is already being filtered thoroughly by international team with a professional conduct. So they are merited to be considered as the internationally recognized paper, and I think I should say this to encourage the more and more our participations in the future, especially among the youth and among the young professionals, to work harder and share whatever you have been doing with result, and hoping that those results will be benefited for everybody, for the community, for the sake of technology and science. And I think this is the most important one. And especially in this occasion, I should mention that we are very, very happy that AGERS has been attended by many experts all over the world, especially back in the West, from Morocco and from Libya, and also from the UK, and also from Japan. I hope, and India, of course. Sorry if I'm still missing in spelling any one of those. But however, this is already, in my opinion, AGER has been achieving, in my opinion, a good step in improving the quality, and also increasing the acceptance that our conference could really be a platform for those who would like to promote technology and science for the sake of the people. But I I have to allow me. Then I have to to read the results of the what you call it, the sorting out the paper. I think this is the best among the best. First, best student paper award will be given to Mamuda Bello Inua, Zangke, Xingyuan, and Aslam Asim, with the paper. The title would be a multi-scale segmentation framework for uncompleted building footprint extraction from remote sensing imagery. Okay. Then should I go thoroughly with the lecturing of this the committee? Please take with me. Should I continue?
Mr. Mamuda Inua still in the room. Maybe you can spotlight with the Mamuda to get the picture.
Yeah. Please.
If there is still in the room.
Mamuda Bello Inua.
He's not present.
It's not present. What about Zangke? Sorry? What about the second author or third author and fourth author? Okay, it seems if there isn't any of them, then this best student paper award will be communicated through email. Okay. Secondly, the best student presenter award will be awarded to Muhammad Faisal. Spatio-temporal analysis of air pollutants changes during the COVID-19 using Sentinel-5P and Google Earth Engine case study Java Island. Is Muhammad Faisal there?
Spotlight.
Yes, I'm here.
Okay, congratulations, Faisal.
Spotlight.
Thank you so much for this.
Yeah, congratulations and have a good continuation. Okay, then Best Presenter Award will be also given to Swasatyo Yulianto. Swasatyo Yulianto on spatial distribution of padi growth stage using Sentinel-1 based on card model. Is Swastio is there? Anyway, applause for him. Yeah.
Thank you for the award. I can't. It's not. It's beyond my expectation to receive this award. Thank you.
Are you Swasatyo?
Yes, I am.
Swasatyo.
I am
okay. Congratulations, Pak Swasatyo. Congratulations, Pak.
Yeah, thank you. It is beyond my expectation. But again, thank you for the award.
Yeah. Hopefully, you will be having good continuations in your work and your career.
Yes, certainly does.
And please be participating in our future conference. Okay. Next, last but not least, is the Best Paper Award. Best Paper Award will be given to siapa nih? Fabio Tosti, Valerio Gagliardi, Luca Blancini Ciampoli, Andrea Benedetto, Su Triader, Amir M. Alani, for the paper entitled Integration of Remote Sensing and Ground-Based Non-Destructive Methods in Transport Infrastructure Monitoring, Advances, Challenges, and Perspectives. Congratulations, gentlemen. I hope this will be memorable for you and for us, and meaning that we are in one platform. Okay, so you are a part of AGERS. And thank you, and have a good continuation. I think that's all. And once again, I would like to thanks to the committee, committee headed by Dr. Iqbal, and with conference chair Dr. Agustan and Oni Bintoro MSc, and also to the MCs, and also to other committees. The MC name is not put there, so I can I cannot read your name. You should have been writing down your name there, so that everyone will know you. Okay. And to the committee, I cannot mention one by one, but the one which is already here, I will read it. Committee Brian Fauziah Cahyan Ningsih and Zilda Dona and Nurdiansa, and so on. And thank you very much. And I will return back the stage to our MC. Please mention your name. I'm not quite familiar with your name.
Okay, my name is Gita.
And my name is Nico, Mr. Dr. Arifin.
Okay, Gita and Nico.
Yes.
Thank you very much.
You're welcome.
Okay, thank you, Dr. Arifin Nugroho. And to all participants, once again, please give a big applause reaction for our winners.
And also, Professor Arifin, don't forget to our presenter from Libya, Morocco, Oman, and other countries.
Yeah, correct. Yes, of course. Actually, I've been a little chat with those experts, and we are very, very glad that we could get together among among what you call it, among countries having kind of similar culture and also similar situation.
But time difference is very big, yeah, Professor Arifin Nugroho. The time difference, maybe what time difference in the Morocco, and then what time now, right now in Jakarta, already 4 o'clock, afternoon.
But actually, this kind of in the virtual world, I think time difference should no longer be a problem, because everyone can get to anyone wherever and whenever. So there will be no problem. And this is the beauty actually of the internet conferencing, so that we can get together, we can feel the atmosphere, and also the emotion, we can feel it. So I believe we could get together, and we could get more closely to everyone, and in each countries, including also those in the Middle East and in Africa, in Saudi Arabia, in Oman, but also to India, Afghanistan, all the way in the Southeast Asia as well, and in Japan. So we are very, very happy. This time we could manage to have such kind of gathering, excellent gathering. So I should thanks once again to the gentlemen and gentlewomen behind the scene. So without which we cannot be reaching the stage of success of the conference. So I should congratulate you all, and thanks for everything, and thanks for the helps and cooperations. We should maintain it in a better level, and keep on increasing the affection from one to another, because we are families. Thank you.
Thank you, Mr. Dr. Arifin Nugroho, for the speech. Maybe before we end this conference, we will request for some impression from our friends, maybe from Morocco, and maybe from another country, such as Mr. Haydin, maybe from Morocco, which is have 6 hours time difference from here. Could you give some impression about this conference, maybe, Mr. Haydin?
Yes, I can. Hello, can you see me or can you hear me?
Yes, yes.
Yes, we can.
Okay, that's
hello.
Hello.
Assalamualaikum, Haydin.
It is very nice. I hold my presentation at 7:30 a.m. Things I never did. But it was only to say that it was very rich conference. It is something that is amazing, and also people who are organizing are already available, disponible to help if for any simple questions. That is very nice, and I hope that for next year, that even if COVID-19 is over, so that to have always the possibility to have a mixture for present and also remote participation for people who cannot fly to Indonesia, so that we can always have the opportunity to participate even remotely.
Thank you.
Thank you, Mr. Haydin. Maybe once again from Miss Elizabeth Tarazona, which have 12 hours difference from
Jakarta.
here. Could you give some speech for the impression for this conference?
Hello, are you listening?
Yes, we
Yes,
could.
yes.
We can hear you.
Clear, clear. Yes, we
Is
can
that
hear.
here? Oh, oh, hi. Oh, the presentations are very interesting. Really, I really grateful for my opportunity to participate in this event. Thank you very much. I am from Peru in South America.
Oh my God.
Thank you for all the impression from presenters. Ladies and gentlemen, please kindly click the link on the chat room for SE certificate and presentation from the speakers before leaving this Zoom meeting.
Ladies and gentlemen, now we will end this conference. Thank you for all the speakers, all the presenter, participants, and commit or AGERS 2021. We hope next we can collaborate. Yes, for next research maybe or next conference. And before we part, please accept first or pantun from us. Wandering to the market, don't forget to buy bread from my sister. If you feel so sad, remember the next day will be happier.
Kalau ada jarum yang patah, jangan disimpan di dalam peti. Kalau ada silap dan salah, harap sudi maafkan kami. Which roughly means, please forgive us for our shortcomings.
Till we meet again, perhaps in next time or next conference, and may all of you always safe and healthy.
Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
すみません、大内です。なんか、
はい、先生。
また私になくなってね。
ありがとうございました。
みたいで、昨日。
Arigatou gozaimasu, Sensei. Sensei Ouchi.
Thank you very much for all the participants.
Thank you
Hopefully the corona pandemic will finish and then we can conduct the offline meetings, the offline conference, maybe in Bali or Batam or Jakarta. So see you next year. Hopefully we can meet face to face.
Yeah, yeah.
Directly.
Amin.
Amin.
Oke, terima kasih semuanya. Thank you all.
Thank you.
Terima kasih,
Thank
Pak.
you, Pak Arifin.
Luar biasa.
Terima
Thank
kasih.
you.
Thank you everyone.
Thank you. Thank you. Selamat ya. Sampai ketemu lagi.
Terima kasih Pak Gustan, Pak Ketua. Sampai ketemu lagi.
Sampai ketemu lagi ya. Mas Iqbal,
Ya,
terima kasih.
terima kasih Pak
Kesempatan.
Arifin.
Ya, oke.
Luar biasa.
Terima
Ya,
kasih Pak Bangun.
sampai ketemu lagi.
Ya, sampai ketemu lagi di tahun depan.
Terima kasih di tahun depan. Oke, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Luar biasa.